People have been saying that 2025 is the year of agents, but what does that even mean and how can you get started with them? In this new series, I'm going to be teaching you all about the new OpenAI Agents SDK so that you can understand that. So we're all familiar already with large language models like ChatGPT. You send in a message and it gives you a response. Agents, though, are basically large language models with a specific task, and they are given tools that they can autonomously run to achieve that task. So for example, I can create an agent that uses the GPT-4o model and give it a prompt that tells it that its job is to help me plan my day. I then give it access to my Python functions, such as one to check my calendar for available time slots, another one that prioritizes tasks based on deadlines, or even one that sends reminders directly to my phone. You can then invoke that agent and it decides completely on its own when to call these functions because its job is to achieve the task that you give it, given whatever tools that you give it. Another very powerful capability is letting agents collaborate by handing off tasks to other agents, effectively creating a team of AI assistants or agents that can help you accomplish any task, or just tasks that are too complex for a single large language model. So for instance, your daily planning agent could delegate booking a restaurant reservation to another agent specialized in managing reservations. Or it could pass off detailed research tasks to another agent specialized in doing web research. This teamwork between our agents or our large language models streamlines complex tasks and breaks them down into a much more manageable set of tasks because each agent can focus just on what it needs to do. So there's many libraries out there right now for building these agents, but one that just dropped very recently at the time of recording is the OpenAI Agents SDK. It's a framework for building the agents I just described in a very, very easy way using Python. So once you have finished watching this series, you are going to have a great understanding of the library to be able to build all kinds of agentic applications. I promise you, since this is such a popular topic nowadays, this is not something that you want to pass up on. So what do you need to know to actually watch this series? First, you just need to understand Python because we'll be using Python to use this library. Another thing is a basic understanding of large language models, so you should just basically know what ChatGPT is and how it generally works. You have a model. The model usually has a system prompt that tells the model how to act, and then you can invoke the model using a user message, and that can give you a response from the model. That's kind of it, nothing too complex. So if you know both of those things, you will be successful, I think. So what will you learn in this series, though? The more interesting part. So first of all, you're going to learn how to create agents. You'll learn how to configure them. You'll learn how to do structured output, which is just making sure that your output of the model conforms to a specific class model. Another thing is tool calling. This is very important. I told you about before. You can make it so your agents have the capability of calling Python functions or tools, and it can decide on its own when to call those tools, if at all. Really, really powerful. But also what's really powerful is handoffs, which is making it so that an agent can pass off control to another agent. So essentially giving agents the capability of working together. Another thing we'll learn about is tracing. So this is a cool tool that OpenAI provides. You can basically trace the actual execution of the program to see what agent is being called, what the agent is doing, the input, the response, what tools it's calling, what agent is being handed off to. It's just a logging feature essentially that's really useful. Besides that, we'll also learn about streaming, so we can stream text back as it's being sent by the model. We'll also learn how to do multi-turn conversations, so just basically having a back and forth conversation with an agent or a model. The next thing is guardrails, so making it so that we can validate the input to make sure there's nothing bad in the input that we don't want, and also the output as well, making sure that the model does not output anything that we don't want. Finally, we'll go over agentic patterns, which are just common design patterns that you can use when designing your applications that use agents. So as you can see, guys, there's a lot to learn, so hopefully you're excited about that. We're going to end the series by making a cool deep research tool. This is just a simple console application. Deep research tools are very popular now with ChatGPT, Gemini, and also Grok. So I just wanted to implement this from scratch myself using the Agents SDK. So basically you just input a search query and you enter, and then behind the scenes a bunch of agents are going to work together to answer your question. So we could ask something like, is fluoride harmful? A very simple question, but it could, take some extensive research to figure out. So once we click enter, it's going to start researching. It's going to figure out what queries to search the web for. So these are some of them. And it's just going to search each one by one. Then it's going to use an evaluation agentic pattern that we're going to learn about to evaluate if it needs to do more research. If it does decide that, it'll do more research. Once it's finished, though, you're going to get a full report using Markdown with a table of contents, a introduction and conclusion with sources of the answer to your question. So this is very detailed. You can make it even more detailed than this and also use a more powerful model. There's also a web version for this that I'll have the source code for. I'm not going to show you how to make it, but it's a really cool web application that goes along with this. But you're going to see how to make this from scratch using agents, and you're going to learn a lot from it, I think. So I think it's a great way to end the series. So if you're excited to see how to do that, then keep watching, and I'll show you how. Let's talk real quick about where you can find the code for this series. Under every single video, you're going to see a link to this GitHub here where you can see all the source code for every single video in this series. When you come here, there's also going to be a table of contents README, so you can go into each individual file. This will have more when I actually finish setting it up. It also has some setup instructions as well, which I'll be showing you guys next. But yeah, come here to get all the source code for every single episode, stare at the code to get a deeper understanding of it. This is for you to utilize, okay? So make sure to check this out. Another great resource is our Discord community. So there's going to be a link in the description for that as well. Make sure you join that because there's other programmers just like you who like learning about these kind of concepts that you can talk to. You can also join to give me suggestions on new videos if you want to, or just leave a comment. Another great source of information that you'll need for the series is the OpenAI Agents SDK official documentation. I'll have a link for this in the description below, of course. But yeah, this is just documentation from OpenAI themselves that explains how to use every single feature of their library. So if you honestly just want to not watch my video, you don't have to, but I try to explain a little bit better than this. I go into a little bit more detail, at least I try to. But a lot of my examples are going to be based on this or modified based on this. And it's just a great resource. If maybe I don't explain something as good, you can come here and try and find some more documentation on it. It's always great to have more than one source of information, okay? So make sure to check it out. Alright guys, I really hope you're excited to learn. We're going to learn all about the OpenAI Agents SDK to learn how to make agentic applications. Let's get started. Before we start actually coding using the OpenAI Agents SDK, I want to show you guys how to set up everything. Feel free to skip this video if you already know how to do all of this stuff, but in this video I'll be showing you guys how to set up a local Python environment, how to install dependencies, how to create a Jupyter notebook and run it, how to create an OpenAI API key, and then how to set it up with a local .env file that you can grab in the notebook. So if you don't know any of that, or maybe you know some of it, this video should be very useful for you. So I'll just show you the basics. So first of all, this is VS Code. You can use any IDE that you prefer, such as PyCharm, whatever you want to use, right? But VS Code is a very popular option. And usually the very first thing that you want to do when setting up a new Python project is to set up an environment. There's a bunch of different ways that you can do that. There's different things like Anaconda and stuff like that. But we're just going to use a standard local Python environment. So just first open up a terminal to your project's root directory. Just make sure you have Python. So Python-v. I don't know why it spams all this, but you can see that my version is 3.12. So just make sure you have a modern version of Python like 3.11 or 12 or anything close to that or above that should be fine. So to create your local Python environment, do python-env, which stands for virtual environment, and then give it a name. So commonly you just call it venv as well. So we're simply creating a new virtual environment called venv. That will do it. So it's going to be represented by this folder here. So whenever you commit anything to Git, for example, to a Git repository, make sure you ignore this file. This is something that should be only local to your computer. Now, once you have your Python environment set up, before you install any packages at all, you need to activate the environment, or else they'll be installed globally on your computer. So on Linux or Mac, you can run it by using the source command, so source venv, or your environment name /bin/activate. On Windows, though, you can do /venv scripts activate. And now it's activated. So you know it's activated simply because it shows the environment name in the terminal. So if you don't see that, you should be a little concerned usually. Okay, so now we're good to go to actually install packages. So when you're installing packages for a Python project, there's two ways you can do it, or there's more than two, but two of the major ways that we can do it in this tutorial series is by installing it using pip. So pip install and then the package name. So we could do, for example, OpenAI Agents. This is actually the name of the package that will bring in the Python library for the OpenAI Agents SDK. So let's run it. So this will install it locally and all its dependencies to our Python virtual environment that we just created. So that will give us everything that we need. Let's also install another package called pip install python.env. This will allow us to bring in a .env file to get environmental variables. I'll show you that in a second. So one thing that you can do that's very helpful when you have a Python environment is to create a new file called requirements.txt within the same directory. And inside of here, you simply list all of the packages that your project depends on. So for example, we could do the one that we just installed, which is OpenAI Agents, and also python.env. The benefit of having a file like this, the requirements file, is that whenever you install this project from fresh, maybe you clone it from GitHub or somebody else's project, you now have a way of knowing all the different dependencies that the project depends on. So now anytime I want to install a Python package, I can either run the command manually to install it, or I can add it first to my requirements and then install everything and keep everything up to date by doing pip install -r requirements. So this will install automatically any requirements that you don't already have from that file. Alright, so that's how you can set up a local Python environment and also set up your Python dependencies. Now let's go ahead and see how we can make a Python notebook. So first of all, within VS Code, there is an extension for this. It may not be installed already, so just go to extensions and then just search Jupyter. It's called Jupyter. So click Jupyter, and this is going to be essentially an extension pack of a bunch of different extensions that you can install. So just install it, and this will give you everything that you need. Okay, let's create our very first notebook. We'll call it hello.ipynb, so Python notebook. I'm assuming if you're watching this, you know what a notebook is, but I'll just give you a basic overview. You can create code cells, which has Python code, and then markdown cells for documentation. So you could have stuff like hello world, and then you could display that like that. It actually renders as a cool documentation text, or you can print hello. But as you can see, there's no syntax highlighting here because what we have to do every single time we create a notebook, we need to target the notebook onto our local Python environment or something else. So we'll do Python environments and then select the local one, not the one for your entire computer. So it'll be this one, VNV scripts Python, select that one. And now you can see the syntax highlighting because it does recognize your local Python version and your dependencies. Now we can run this code cell by clicking the play button. And now it's going to ask you if you want to automatically install this ipykernel package to your Python environment so that I can actually run the notebook. So let's do that. It makes it really easy for us that it does it automatically. There it is, it's done. So it printed hello and ran the code. So that's how you can create a Python notebook and run some code inside of it. We're going to be using these a lot to learn how to use the library. Now the third way to install Python packages is directly in the notebook. So you may see me do this sometimes just to make it clear what I'm installing. So a way to do this is you do %, and then the command pip install, and then the package name. So I could again do OpenAI Agents. So what this will do is since the notebook is targeted to my local Python environment, if I run this will install the package if it's not already installed in my local Python environment. Really the only downside of doing it like this is that you lose track of what you may have installed in certain notebooks. It's kind of better to just install them or write them down in your requirements and then do that command I showed you to install everything in your requirement so that you ensure that every notebook has access to all the dependencies that it needs. Alright, so since we're using OpenAI's Agents SDK, behind the scenes it's going to use their models by default, which is great. It makes it easy for us. So what I'm going to do now is show you guys how to obtain an API key and then how to store it as an environmental variable on your computer so that when we run our code, it's able to grab the API key and actually use it so that you can run models yourself, okay? So first things first, go to platform.openai.com. Just make an account or sign in using Google. It's pretty easy. Once you have done that, then go to settings. Once you've done that, then go to billing and just make sure that you have some credits here, like add a couple dollars because these models are really cheap. So I would say if you have the money, just add like $5 and that's going to last you a very long time because they're so cheap. So just add a payment method, add a couple bucks or maybe $1, just, not a lot of money. Doing this will give you access to actually run the model. So we can get an API key, but that doesn't mean you can actually run any models because it costs money. So once you do that, you can then go to API keys. Now let's add the key. So we'll click create a secret key. So just give it a name. A common thing that you can do is just have a different key for different projects. So if you ever need to delete the API key, it will only delete it for that project and you'll know which project it's for, not for like your whole computer or whatever. Okay. So either create a key for your entire computer or for a specific project. It doesn't really matter. Just give it an informative name like, I don't know, potato. After that, you can set some permissions like all or restrict them to specific models and capabilities. So if you want to lock it down, you can. Make sure you also click default project and then click create key. So now make sure that you copy this right away because if you close this, it will be hidden forever. You'll have to create a new one to see it again. So copy this and now we want to put it somewhere safe. We're going to put it directly in our project so we can start using it right away. So go back to your project, and what you want to do is create a new file called .env. It's literally just .env. It's a local environment file. There's no actual name. It's just the extension, okay? It's a hidden file. So this is a place where you can store your local environmental variables for your project. So we can store the OpenAI API key, $, and then paste it. Paste the one that you just grabbed from OpenAI. So it has to have this name, by the way. Make sure it's OpenAI API key with underscores. Because whenever you run any OpenAI library code using Python or other languages, it's going to be looking for this key specifically, this environmental variable. So just make sure it's that name, okay? But now we need to set it up so that our Python notebooks can actually grab the environmental variables from the local env file. So that's why we installed previously this package here, python.env. This will allow us to do that. So let's go here to our notebook, and what you want to do is to import OS, and then also do from.env import load.env. First things first, we're going to call this function load.env, and that's it. So this will literally just load the keys of the environmental variables from the local.env file if there is one. And so now when we run any code using the OpenAI library, it will automatically grab that key and use it. OS is so that you can do this piece of code if you want to add this. This will just try grabbing it on its own or manually and checking to see if it exists, and then it'll raise an error if it doesn't exist. This is just a helpful piece of code you can add to your notebook so that you don't try running any code before making sure that you actually have the key set up. So let's run and see what we get. So nothing happened because it was able to grab the key, but if it wasn't able to, then obviously there would be an exception. So you know that you need to fix this issue before writing any code. Okay, so that's pretty much all I want to show you guys. This is all the setup that you need to do to get started in this series. So the next part, I'll be showing you guys how to actually get started with the OpenAI Agents SDK. After watching this video, you guys know how to create a Python project, create a local Python environment, install packages, create a Python Jupyter notebook, create an OpenAI API key, and then set up a local env file so that you can store the API key to be grabbed as an environmental variable. Hopefully you're excited for the next part. Stay tuned. In this part, I'm going to explain to you what are agents, how we can actually create them and use them, and then finally how to do structured output with agents. So agents in essence are large language models that accomplish a specific task. It's a pretty broad definition, so they can be supplemented with tools, structured output, and also hand off to other agents to work together. So we'll be learning about those things. So it's basically just an abstraction over the regular GPT that unlocks more capability. So the first thing that you want to do before getting started is install the OpenAI Agents package and also python.env, which I showed you guys in the previous video if you watched that one. The most important one is installing this because that actually lets you use the library. And then this package is just going to be for the loading the environmental variables from a local.env file that we learned about. So just go ahead and run that and it'll install everything. Now we could do this piece of code here. So this will load in your local.env file that has your key in it that we saw how to do before. So it has our OpenAI API key. And then we can load that in if it's not loaded already. So now when we use the OpenAI library, it actually uses the API key automatically, okay? So now that we have that, let's see how we can actually create our very first agent. So we'll do from agents, import, agent, and runner. So to make an agent, we'll do agent is equal to agent. An agent is going to have a name, so we could say something like, I don't know, basic agent. And then also you want to give it some instructions. Instructions are just telling the large language model how to act, what the agent should do. So a very basic prompt that we could give it is like, you are a helpful assistant. And then we can also say something like, respond only in all caps. That's it. So now anytime the model that's behind this actually responds to you, it should respond using these instructions, okay? So now that we have an agent, let's see how we can actually run it or invoke it to get a response. So we'll do result is equal to await runner dot to run. We're going to pass in the agent that we're trying to run, and then the prompt. So the prompt is just like when you open ChatGPT and send a message. This is us sending a message to our agent to get a response, and it should hopefully be in all caps, right? So we're going to say, hello, how are you? And that's it. So now it's just going to invoke it. It's an async method, so we need to await it. But once we have the result, we can then do result.finalOutput, which gives us the actual response as a string, okay? Let's try it out. There we go. Hello, I'm doing great. Thank you. How about you? So it's yelling at me because we told it to respond in all caps. So that's how you create an agent. It's just backed by a large language model, and it responds using these instructions here. Very, very simple. So you can also give it other information, like you can provide a model. So by default, it's going to be using the GPT-4o model, which is like the most basic model right now at the time of recording that is used for ChatGPT. So whenever you open ChatGPT, this one is probably the one that you'll be using. But what you can do is swap it out for other models that are available to your account. So right now I'm logged into my OpenAI account. I'm on the models page, and here's a full list of all the models that they offer. So we have stuff like GPT 4.5, which just came out at the time of recording. We have O3 Mini, which is a reasoning model. I think I have access to this one. I'm not too sure. So let's try it out. It's just called O3 Mini. So we'll go back to our code and replace it with O3 Mini, and let's see what we get. There we go. Hello, I'm doing great. Thank you for asking. How can I help you today? So it did work as it seems. A really great and cheap model that you can use is GPT-4o Mini. It's called Mini because it's a smaller model and it's faster, but it just has less good quality in terms of its output, but it's way cheaper. So for example, this one says 15 cents for input. I believe it's per 1 million input tokens. But if we go back to GPT-4o, it's $2.5. So you can see it's way cheaper. So if we go back to our code, we can swap it out. So we'll do GPT-4o Mini. So I think while you're testing, I'd recommend using one like this. It's way cheaper, way faster. And then if you want to actually deploy your application and get better results, you just swap it out for a better model, right? There we go. Hello, I'm doing great. How about you? Let's create another agent. So we'll do joke agent is equal to agent, and we're going to give it a name of joke agent. So the task of this one is you are given a topic and you need to tell a joke about it. That's it. So let's see how we can do this. We need to give it a topic and then it's going to give us a joke about the topic. So let's make a topic variable. Topic is equal to AI, and then we'll say result is equal to await runner dot run joke agent, and then now we can just pass in our topic as a string. And let's see what we get. So we'll do results dot final output. Why did the AI break up with its robot girlfriend? She had too many unnecessary updates. Okay, nice. We'll give it another topic. I don't know, boogers. How about that? Why was the booger always invited to parties? Because he was a real pick-me-up. Oh, nice. Okay, I get it. I was late. Now, the whole point of having an agents framework, such as the OpenAI Agents SDK that we're using, is that you're going to have multiple agents that sort of work together to accomplish a task or a set of tasks, right? But each agent is responsible for only one specialized thing, as I've told you before. And I think the reason for that is pretty intuitive, because if you tell a human being as well, here's a list of things, do all of these things for me all at once, please. It's not going to be as good as telling like 4 different people do all these individual things, and they're going to give you much more high quality results, and you can combine them together essentially. Okay, at a very high level, that's the same idea behind agents as well. Okay, so as another example, we're going to have this language agent. So it's going to be a language expert. You are given a joke and you need to rewrite it in a different language. So now we have 2 agents. We have the joke agent, so it creates the joke, and then we have the language agent, which rewrites the joke in a different language. To make these work together, one thing that you can do is have the joke agent's response fed into the input of the next agent, which is the language agent. That's a deterministic way of connecting agents together to work together, okay? The way we'll do that is by doing a joke result is equal to await, and then we're going to do runner run joke agent again, and then we'll say topic. And now we want to pass the result of the first agent to the input of the second agent, our language agent. So we'll do translated result, await, runner dot run. And now for the input of the language agent, we're going to do this here. So we're going to have a template string. So translate this joke to Spanish, and then we're going to say the actual thing that we want to translate, which is the final output from the joke result, the first output. So let's see what all that looks like by doing this here. So we're going to print the original joke of the first output, and then print the translated result from the second output, okay? Let's run it and see what we get. So the original joke is, why did the booger stay in school? Because it couldn't stop picking up new things. And then the translated joke, because we're translating it to Spanish, is ¿Por qué el moco de cuero en la escuela? ¿Por qué no podía dejar de aprender cosas nuevas? Now, I have a very basic understanding of Spanish. Yo hablo poco español, but that looks about right, so it worked. Pretty cool. Of course, you can make this even more advanced by having it accept a language dynamically. So you could, get input from the user, for example, and then pass that into the template string that you craft before passing into the language agent. But that's it. So that is how you can create agents using the OpenAI Agents SDK. It's really easy. All you gotta do is give them a name, some instructions to follow, and then if you want to, you can specify a model to use as well. And then if you want to have agents work together, you simply run one agent, take the output of the first agent, and then pass it in as input into a string to the second agent. Really easy stuff. All right, now we're going to see how we can do structured outputs with our agents. What it is, it's a way to get the large language model to provide its response in a specific format or schema. What I mean by that is usually your large language models give you the responses just as strings, but what if you wanted to give you a JSON object or an actual class, so that way you can just directly use it in your code in a more structured manner? It really can't do that unless you use structured outputs. So with our agents, we have something called an output type, which is just a way of using a structured output behind the scenes. Let's just see how we can do it, and then you'll see why it's so useful, okay? So we're going to do from Pydantic import base model. Because to do an output type, we're going to model it based on a Python class. So we're going to do from agents import agent. We've already done this above, but I'll do it again. So we're going to do class, and we'll say something like recipe. We'll extend from base model. And so this class here will represent the output that the model is supposed to give back to you as an actual structured schema. So just think about what you want the agent to be able to provide. So as an example, I have a recipe model class, which is going to have a title. Every recipe has a title. It's going to have a list of string ingredients, a cooking time as an integer. We'll tell it to provide that in minutes, and then also the amounts of servings. So now we're going to make a recipe agent to go along with that. We'll give him a name, recipe agent. So here's the instructions. You are an agent for creating recipes. you'll be given the name of a food, and your job is to output that as an actual detailed recipe. The cooking time should be in minutes so that it knows, to provide that in minutes. I think you can come up with a better prompt, but I think this one is good enough. So once you have that, you can then provide the output type, which is just going to be your base model that you created. And this forces the model to return any output, not as a string, but as this actual type here, okay? All right, let's invoke it now. So we're going to do recipe agent. Then now it's asking for, remember, it needs the name of a food, and it's going to do the rest of the work. So we're going to say Italian sausage with spaghetti, and let's just run and see what we get. Okay, so we're going to do response, and again, you just do final output, and it should be just be as this type here. So let's run it and see what we get. Here we go. So we got recipe. You can see that's an actual object type just by the way it's printing it out. It says recipe, and it's got a title, Italian sausage with spaghetti. Ingredients, 400 grams of spaghetti, 4 Italian sausages, casings removed, 2 tablespoons olive oil, 1 onion finely chopped, 2 cloves, blah, blah, blah. Optional stuff, very detailed, that's good. And then cooking time is 30 minutes, and the servings is 4 servings. Really cool. So it looks like it works perfectly. So now what you can do is take this recipe type that you have. So we can just do simply recipe is equal to this. Now, hopefully you can see the benefit of having a structured output, because if you have an actual Python application, it makes more sense for a lot of your responses to be actual Python types like recipe, because one, it conforms to what you actually need, but also you can just directly use it in your code as a recipe type because this is valid Python code. If this did not exist, what you would have to do is essentially in the prompt to beg it to return a JSON output and then parse it and then convert it to a recipe type. That's a lot more work. And since you have to really try and get the prompt right to, prompt engineer it into actually giving you that response, sometimes it won't. That's a lot of extra work as well. So this really simplifies things. Okay, guys, so now we're going to talk about something really cool. I think this is when agents start to get really powerful, which is allowing our agents to do tool calling. Tool calling is a way to extend the capability of a large language model by allowing it to call external tools or APIs. This will be useful specifically for tasks that require access to external data or services. In other words, what we're going to be able to do is allow our agents that we create to actually run our Python functions. We're going to give it access to any Python function that we define so that it can decide to use it if it wants to achieve its task. So we'll do from agents, import agent, and also function tool. We're going to use function tool to mark a Python function as an actual tool that can be used. So we'll do define get weather. Getting the weather is a very common example. So we get the weather. We can accept a parameter. So we'll say the city, and we'll have it expect a string as the return value. I'm going to have it print this message so that we know when this is actually invoked or not. And then to return the actual data, what you would do here is obviously hook this up to an actual weather API, but we're just going to simulate that to make it easier for us. We'll simply say the weather in city is sunny. So the idea is we're going to create an agent, and it's going to be a weather agent. So the instructions that you could have for this is you are the local weather agent, you are given a city, and you need to tell the weather. Now with this agent by itself, it doesn't have any tools hooked up to it yet, so it doesn't really know it can call this function to get the actual data, so it would probably just make it up. But to actually hook up a tool, you can do tools is equal to, and it's going to be a list, and then you just simply provide the function name, so get weather, and that's literally it. So behind the scenes, it's handling all the stuff like telling the large language model it has access to this function that it could use, and it tells it the signature of the function, like it accepts a string city, it returns a string, and all that stuff. It tells it that, so you don't have to worry about it. So now whenever you invoke the agent, it's going to decide on its own whether to call the function or not. Now, since we told it it's a local weather agent and it needs to tell the weather based on a city, it's smart enough to know, okay, I'll just call the get weather function, get the actual weather, and then use that to craft a response. So I'm going to say, what is the weather for Dallas? And so let's try it out. So it says getting weather for Dallas. This is this here. So we know it did invoke the function. And then it says the weather in Dallas is sunny. So literally just use the output from the function directly. But if we want to, we could just simply have it say sunny. So the only thing that the model is getting back from the function is, what the weather conditions are. And then it will use that to actually craft a response for you properly. It's not going to just say sunny. So let's try it out again. There we go. Getting weather for Dallas. The weather in Dallas is currently sunny. So it's able to actually give you a dynamic response based upon the information that it's able to grab from a function call. I don't know about you guys, but this is pretty insane. We're literally giving the large language model the capability, or the agent rather, the capability of deciding on its own while it's essentially thinking whether it wants to invoke a tool or not, or a function. And then it's going to use the response from that function to, again, come up with an actual response. We can actually extend this with multiple functions. So we could say get temperature as well, getting temperature for city, and then we'll say something like 70 degrees, right? So now we'll say you are given a city and you need to tell the weather and temperature. And this is why it's also really good as well. You don't have to tell it, call the function. You could if you want to. That would actually help reliability sometimes if it gets more complex. But with basic stuff like this, you don't have to tell it to use the function. It's smart enough to know it has access to the function and it calls it automatically. So now if we run it, so we need to make sure that we also add the tool here. So get temperature. And there we go. Now let's try it out. Getting weather for Dallas, getting temperature for Dallas. The weather in Dallas is currently sunny with a temperature of 78 degrees. That is awesome. So if I remove these tools here, it does not have access to these functions anymore. So if I call it, let's see what happens. I'm unable to provide real-time weather updates. However, you can check a reliable weather website, blah, blah, blah. So it knows that it doesn't have access to the functions anymore, so it cannot give you accurate data. If you want to, of course, you can just tell it to make it up, but it's kind of smart enough not to do that. It kind of assumes you don't want it to do that, hallucinate. Another cool thing is that if you change the actual prompt that you're feeding into the agent to say something like, how old is the moon? Something totally irrelevant to weather. This has nothing to do with agents, but the model itself behind this is smart enough to know that you're asking something totally irrelevant from the instructions that you gave it. So it's usually going to tell you, I can't really help you with that. Oh, in this case, it did not. But that's just an issue of prompt engineering, which means that you want to give it a more detailed prompt, like tell it. For example, we could say, for any unrelated queries, say, I can't help with that. Of course, you'd make it, better, but that's a basic way you can do that. There you go. I can't help with that because I said how old is the moon, but if I say Dallas, I get the temperature for Dallas. Perfect. Now, what's really cool about the Agents SDK that OpenAI provides is that they actually have a couple of their own built-in tools. One of them is really powerful. It's the web search tool. So you could do from agents import web search tool, and now we can create something like a news agent. So we'll say news agent. It's a news reporter agent. So we have our news reporter agent. You are a news reporter. Your job is to find recent news articles on the internet about U.S. politics. So you're giving it instructions, and then you're also giving access to this tool, which is again provided by OpenAI directly, called the web search tool. And what this will do behind the scenes is literally search the internet. So a hosted tool that lets the large language model search the web, currently only supported with OpenAI models using the Responses API. So behind the scenes, it's figuring all that out for you. So you're literally giving it access to this tool here. It knows how to invoke it automatically. It knows what it's for. So we can invoke it with a very simple message like find news. And it already knows it's supposed to find recent news articles about US politics. So it should do that using our tool here. So let's try it out. So here we got our results. You can see it's very detailed as a list of sources at the very end here. But Democratic Party's internal challenges, blah, blah, blah. Donald Trump's influence on cultural institutions, blah, blah, blah. Looking over this just now, it does seem to be very relevant to what's going on right now. So this is a very useful tool when you need to augment your agents with up-to-date information from the internet. Because of course, if you don't give it access to the outside world in terms of what's going on, it's just going to make it up a lot of times. It's just going to hallucinate, and you don't want that. Now, something you have to be aware of is the pricing for this tool. It is an actual official tool by OpenAI. So you have this section here for built-in tools. You have the web search tool call. It says that for GPT-4o and GPT-4o search preview, it is $30 per 1,000 calls, up to $50 for 1,000 calls, depending on the search context size. So you can configure it with different sizes. Medium is the default for how much information it could fetch, essentially, it looks like. So as you can see, this is pretty expensive. For every 1,000 calls, it's $30. If you scale this up, it gets pretty expensive. So I recommend being very careful, of course, with how you use this tool. Just don't call it a bunch of times if you're not aware of the costs. So even though it's a great tool that you can use to make your applications, have outside information, you can also use other tools that are either free or pay that are just cheaper that give you similar capabilities. The only difference is that you'll have to define your own Python functions and invoke them yourself rather than just using the built-in function here. But that's not too hard. One free option you can use is something called DuckDuckGo Search, which will allow you to use the DuckDuckGo browser with Python to get search results. So get a bunch of links that, try and answer whatever query you have. But then you have to actually go into those links and actually scrape the websites for content and then process them. Another option is called Firecrawl. This is a really nice tool that has a free plan that allows you to scrape websites really effectively and get parsed data to feed into a large language model and do other stuff with. But this really encapsulates all of that. It does the searching and the processing and scraping for you. I think just knowing that you can use it and there's other options is very important. So hopefully that's helpful for you guys. But overall, now you guys can see why tools are so amazing. They're a way to extend the capabilities of a large language model, but most importantly, you can give your large language model or your agent access to external data or services, because without this kind of stuff here, your large language model is just kind of making stuff up, right? That's only useful to a certain degree. But if you can actually combine your Python code with the agent itself, you can allow the agent to decide to call your Python code, which just unlocks a lot of capability, as you can see, okay? So I made this little Python script here that allows you to do this in a more continuous way. So we're just loading in our OpenAI API key, same as before, using load.env, and then we're creating another news agent. We're giving instructions that says you are a news agent that can search the web for latest news on a given topic, compile the information you find into a concise summary, no markdown, just plain text. And then you're telling it has access to a tool called the web search tool. So given a topic, it should be able to just take all the information on that topic and give you a summary. So that's our agents that we're going to be using. Now we're just going to have an infinite while loop that will every single time ask you for a specific query. So input, and then it's asking you enter your news query or quit to exit. If they type quit, it breaks out of the loop and ends the program. Otherwise, it's going to invoke the agent with the query that you specified using run sync. So let's go into our local Python environment by doing env scripts activate, and then we're going to do Python news agent. Let's see what we get. So enter your news query, we're going to say soda. So it says, in recent developments within the soda industry, major companies are shifting towards healthier beverage options to meet evolving consumer preferences. See that recently, so it's fetching from actual news, which is good. Let's just say something else, like, I don't know, Texas, that's where I'm from. Okay, I read it over, it looks good. And then if I want to, I can do quit. There we go. So that's just a very, very, very basic example of something that you can create using this agent here, an agent with web search capabilities. Okie dokie, so now let's talk about another really cool concept, which is handoffs. Handoffs is simply giving an agent the capability to invoke another agent. So for example, going back to our very first example, where we have our joke agent, and then we pass the output of the joke agent to our translation agent, our language agent. This was us manually taking the output and transferring it to the input of the next agent. But with handoffs, we can make it so that the joke agent can automatically pass its joke to the language agent to do the next step. We're going to do a cool example here. So we're going to make an agent that is capable of generating a tutorial for us. So what I do when I make my tutorials is first I'll make a basic outline in my head, or I'll write it down somewhere. And then I'll take that outline and actually make code out of it. So I'll make a full code example of, like, I'll code the entire thing out, and then within the code I'll have a bunch of comments, right? So we're going to do something similar. We're going to make a agent system capable of first generating an outline. So we'll have an outline agent, and the outline will then be passed to a tutorial generation agent that will actually build a tutorial based on that outline and mark it down so it looks really nice. So it'll be a combination of text explanations and code snippets to explain the concepts in code. So here's our outline builder agent. So it's going to be called outline builder, and then has detailed instructions. Given a particular programming topic, your job is to help come up with a tutorial. You will do that by crafting an outline. After making the outline, hand it to the code generator agent. I'll rename this to tutorial agent. All right, here's our tutorial generator agent. It says, given a programming topic and an outline, your job is to generate code snippets for each section of the outline. Format the tutorial in Markdown using a mix of text for explanation and code snippets for examples. Where it makes sense, include comments in the code snippets to further explain the code. So I think this makes a lot of sense. This is essentially how I would do it. So with the concepts of agents in mind, we have two different agents. They both have a particular task. They both specialize in that particular task so they can do it well, and they're going to work together essentially, okay? There's no tools, but if you want to, you can provide them if you want to give it some extra capability. But now that we have both of our agents, how can we connect them together using a handoff? So first we're going to reorder this. Because the outline agent is going to be invoking or handing off to the tutorial agent, we need to make sure that we have this one first, because we're going to do handoffs. So handoffs, and we're going to pass in a list of the agents that we're able to hand off to. So we're going to do tutorial generator. This is very similar to how we did tools, and behind the scenes it actually is handing off as a tool. That's just how it works behind the scenes. But basically, when you invoke this outline builder agent, it's going to decide on its own autonomously if it wants to hand off to the tutorial generator agent. So that's why we need to be very clear after making the outline, hand it off to the tutorial generator agent. So if it follows the instructions correctly, it should hand it off, and then it should, do the next part, which is actually create the tutorial, okay? So once we have defined our handoff, giving it the capability of actually handing off, we're now going to invoke a response. Tutorial response is equal to await runner dot to run, and we're going to pass in the outline builder because we're starting with this one and it hands off to this one. And then we're going to give it a prompt. So we're going to say loops in Java. So we want to make a tutorial on loops in Java, okay? And then we'll just print the tutorial response final output, all right? Now, something you need to be aware of. Previously, when we invoked a agent, the response that we got back from it was the response of that agent that we invoked. But of course, since we're going to be potentially handing off to a second agent, the response could be that second agent response. So that is what you need to expect. If an agent hands off to another agent, it doesn't return back to the previous agent unless you explicitly give it that capability. So whenever it hands off, it's going to end with the agent that it handed off to unless you tell it to do more stuff, all right? Hopefully that makes sense. Let's just go ahead and run this now and see what we get. Boom, here we go. So now we have a markdown tutorial. You know it's marked down just because of the headers here. Loops in Java introduction. Loops are fundamental constructs in programming that allows you to execute a block of code multiple times. Types of loops. And then you have the for loop. Gives an overview. Gives you a code example. Great. Gives you another example. Let me scroll it up here. Nested loops. Gives you a lot of examples. Yeah, this looks like a great tutorial, I would say. So if you want to, you could take the output and write it to an actual markdown file to look at it a little bit easier. But so far it looks great. Now, one thing that would be cool is if we could also get the outline, because right now it's just giving us the final output using the tutorial generator, which is just the actual tutorial itself. But it would be nice if there was a way to get both the outline that was originally generated and passed to this agent, as well as the output of the agent here. One way we could do that is by using what we learned before, the output type. And we're going to make a type for this called, let's just say tutorial, which is a base model. And so for this, we want both the outline and the tutorial itself. And then we can specify down here, so tutorial. All right, so the way that this works is now, because we're specifying the output type as tutorial, it has to return it in this schema here. And since these are not optional, it has to provide an outline and tutorial. So that will allow us to have both our outline and tutorial in the response. So let's go ahead and try this out. There we go, so we can see outline. It's hard to look, it's just putting it all in one line, so it's hard to actually read it, but we do have our outline and our tutorial, so it's working. So what's great about this is that even though only the first agent is generating the outline, it has to pass that outline to the second agent when it's handing off. So it has access to both, it just wasn't returning both before because we told it to only return the tutorial. So now that we added the output type, it knows that it needs to return both the outline that was used and the tutorial itself that it actually generated on its own. Hopefully that makes sense. I don't know about you guys, but this is pretty awesome. One thing that you can do to supplement this is have a handoff description. As the documentation says, a description of the agent. This is used when the agent is used as a handoff so that the large language model knows what it does and when to invoke it. So what that means is that whenever you have a handoff description on an agent, any agent like this one that can hand off to this one can read the handoff description and know what it's used for. So if I write a detailed description like used for generating a tutorial based on an outline. This is very helpful when, for example, let's just say I have multiple agents that I can hand off to. And if I have an actual detailed description here, this will make it more clear when it's deciding which one to hand off to, which one is the one that it needs. So this one is specifically used for generating a tutorial based on an outline. So because again, this is autonomously on its own deciding what to hand off to. So this will help out a lot. Give it as much information as possible. Let me give you guys another example of handing off. So now we have something called a triage agent. This is usually just when you have an agent that takes an input and decides which one to route to. So in this case, we have a triage agent that takes a user's homework question and then decides whether to route to the history tutor agent or the math tutor agent, or if neither agent is relevant, provide a general purpose response. So it's kind of like a fork in the road. Which one do I choose? Or if none of them apply, then do nothing, just give a generic response, right? So the history tutor is for history, of course. You provide assistance with historical queries, explain important events in context clearly, and then it has a handoff description so that it better gives the triage agent the capability of knowing which one to, hand off to. Same thing with the math tutor. It's going to help with math queries and also has a handoff description. So let's run an example here. We're going to run our triage agent. We're going to ask, how do I add 2 and 2? So of course that's a math question, so it should route to our math tutor agent. Let's try it out. Adding numbers is a basic arithmetic operation. To add 2 and 2, it tells you very detailed how to do it because that's what we told it to do in the math tutor agent description here, or the instructions. If I add another example, how did World War II start? It'll hand off to the history agent. Now, something that would help a lot is actually tracking when a agent is handed off to, because we don't actually know explicitly which agent it did hand off to. We can learn about something called traces in a little bit, which will allow you to trace exactly what's happening, but it would be nice in our code to log somehow what handoff is happening, right? Now, one way you could do this is whenever you're providing the handoff, you can provide just the agent like this, that's fine, or you can wrap it in the handoff function here. So handoff, import handoff from agents. And to this, you can provide more detail. So the agent that you're trying to hand off to, there's a bunch of other settings that you can specify, but another really important one is on handoff. So you can basically provide a function that is called automatically when the handoff occurs so that you can do logging or run some piece of code as a side effect or whatever you want to do, right? So we're going to make a function on math handoff. It needs to have a context as the parameter. So context, run context wrapper, none. It's a little cumbersome to write, and then you can have whatever code you want. So I'm just going to print out handing off to the math tutor agent so that we know that. Here's another one for the history one. So now I'll put here on math handoff. All right, cool. So now this is a little more detailed. We can move that down if we want to. So now when it hands off, it should also call these functions here. Let's try it out so we know which one it's routing to. Handing off to the math tutor agent. Nice. And then handing off to the history tutor agent. Cool. All right, I'm going to give you guys one more example of how to do handoffs because this is such a pivotal feature of the library for agents and stuff like that, which is handing off. We're going to start with a customer service agent. You assist customers with general inquiries and basic troubleshooting. If the issue cannot be solved, escalate it to the manager along with the reason why you cannot fix the issue yourself. So the manager is going to have a handoff description of handles escalated issues that require managerial attention. So you handle escalated customer issues that the initial customer service agent could not resolve. You will receive the issue and the reason for escalation. If the issue cannot be immediately resolved for the customer, create a ticket in the system and inform the customer. So we're going to give it the capability of creating a ticket by adding a tool. So it creates a ticket in the system for an issue to be resolved. So for example, if the website's down, for example, the manager can create a support ticket so the technical team can go fix that. And there's also an ID so we can like keep track of it, right? Pretty standard, I think. So we're giving them the capability of creating a ticket. And so now we need to configure it so that the customer service agent can hand off to the manager agent, right? Here we go, handoffs. We have a handoff. We're specifying the manager agent as the thing that we're handing off to. Now, one thing that we can do, and this is also implied in the prompt here, escalate it to the manager along with the reason why you cannot fix the issue yourself. Something that we can do, which is really cool, is in the handoff specify a input type so that when you hand off to the manager agent, it has to be in a specific type, just like our output type, structured output that we learned about. So as an example, we can create this manager escalation type that has a field for issue as a string and then also why. So this is the issue that needs to be fixed that the manager should address, and then the why is why can you not handle it, used for training in the future. So if the customer service gets an issue and it can't handle it itself, the whole point is that it's going to escalate, right? But we should also say why we're escalating, because in the future, maybe it's something that we can train the customer agent to fix. That's just an example, like a real world scenario. Like if you're asking your boss for help, maybe in the future your boss can help you, like train you so that you don't have to ask for help every time. That's what I mean by this, okay? So we have this type here. We can then go to our handoff thing and do input type. So input type manager escalation. So now, again, whenever it's handing off to the manager, it has to be in this type. So it has to provide an issue and why. One final thing I'll add is a handoff callback just so that we know what's happening. So this time, since we're providing an input type, we also need to provide the input with the type in the actual handoff function as well, just besides the context. So we can just print out escalating to manager agents, the issue, and then also why, just so we know what's happening. So now down here, we can do on handoff, on manager handoff. Okay, hopefully that makes sense. Now we can finally invoke it. So we're going to invoke it using the customer service agent. And we'll say, I want a refund, but your system won't let me process it. The website's just blank for me. So ideally, it's just a customer on your website. The website's blank for some reason. And so they call this customer service agent. They try and fix it, but they can't really fix something if it's just blank. That's beyond their control. So they hand off to the manager. And then the manager's like, okay, I'll create a ticket to address the issue so we can get it fixed for any future customers. And then this one will have the responsibility, since it was handed off to respond to the original customer. So we'll get that final output and print it out. Hopefully that makes sense. Let's run it and see what we get. There we go. So we get escalating to manager agent, customer unable to process a refund due to a blank web page on the website. Reason for escalation: the customer is experiencing a technical issue with the website that cannot be resolved through basic troubleshooting. Creating the ticket for issue. So the manager, so it's passed off to the manager, right? But then the manager decided, okay, I'll create a ticket because, of course, they need to actually fix the issue. So customer unable to process a refund due to a blank web page on the website. The issue needs technical troubleshooting, blah, blah, blah. Okay. And then finally, we're having the final response from the manager back to the customer. So I've created a ticket to address the issue with the website displaying a blank page when trying to process refunds. Our technical team will look into this promptly. Your ticket ID is 12345, which was passed back by the ticket tool function. Thank you for your patience. So there, it worked perfectly. Great. So let's just see an example of it deciding not to pass it up to the manager because not every situation needs that. So we'll say something like, hello, how much are tickets? You shouldn't need a manager to answer that question. So let's see what we get. There we go. Could you please specify which event or destination you are inquiring about for ticket prices? So of course it doesn't really know what I'm talking about, so it's just going to give us a basic response. But there's no reason to escalate to the manager for that situation. So everything is working perfectly. And that's it. That's pretty much all I'm going to show you in terms of handing off. I really hope this concept makes sense. You're basically enabling an agent to decide for itself whether to hand off to another agent to complete some task, right? There's more ways we can make this even more advanced that we'll see in the future, but this is a great start. All right, guys, now we're going to talk about tracing, which is a really cool way to see what the agents are actually doing behind the scenes. So when you do a single agent run like this, where you just do runner.run, provide an agent, and provide a prompt to invoke a response, this is actually being traced behind the scenes, even though you didn't explicitly tell it to do that. So if you head to platform.openai.com and log in with your OpenAI account, and then go to traces, you can actually view every single time you've ran an agent, and it gives you a very detailed flow of actually what's happening. That's what a trace is. So, for example, if we go back to the code just real quick, if we go ahead and run this, let's just run and get an output here. It says, hello, I'm just a program, but I'm here and ready to help you, blah, blah, blah. So if I go now to here and let me reload, here it is. So we see workflow, agent workflow. The flow name is basic agent, which is the name of the agent that we just ran. So basic agent. And so if we click into this, so this is a full overview of how long it took. So roughly 1,100 milliseconds, which is just over 1 second when it was created, the output type. But if you want more detail, click this here. This is it behind the scenes actually working with the OpenAI responses API to invoke the LLM and get a response. So we can see when it was created, the actual model that was used, so GPT-4o Mini 2024. It used 75 tokens total with 47 input tokens and 28 output tokens. The response type was text. But this part's really cool. This is actually the details of the invocation. So the system instructions, which are the instructions of our agent, says, you are a helpful assistant, respond in all caps. And then our input, hello, how are you? And then our output that was generated by the assistant, hello, I'm just a program, but I'm here and ready to help. So 28 tokens. So it gives you a lot of detail about what actually happened when you invoke the agent. And this is obviously going to be very useful so that you can debug and just know what's going on in your application. But this is going to be way more useful when you're doing multiple things. So let me show you. Okay, so if we go back to this example here where we have two agents, the joke agent and the language agent. So we take the output from the joke agent after invoking it and feed it as the input into the language agent, and then we get a final output from the language agent, right? In this case, we're running two different agents, so technically this is going to be two different traces. Obviously, that's not very ideal. This is part of the same program. They're working together. So to combine all of the actions of our agents into one trace, we can do with trace and do it as a function. Do colon and put that inside and just make sure to fix the indentation. So inside of here, you just simply give your trace a workflow name. So we could say something like joke translation workflow. And that's it. That's all you have to do. So anything that you wrap with the trace a function here will be part of the same trace. Okay, so no matter how many agents you invoke and everything like that, it'll be part of the same thing. So let's go ahead and run it and see what it looks like. Okay, so if we come back here, let's reload the page. And here we go, our joke translation workflow. We can see that it's a little more detailed, it has a different color, and we have it showing that we first invoked the joke agent and then it went to the language agent. So let's click it. So it tells you how long each agent took, which is really cool. So the joke agent, the initial instructions were you are a joke teller, blah, blah, blah. The input was cheese, and then we got a joke based on cheese. And then we see the language agent. We can see the exact input to that. So you are a language expert, you are given a joke and you need to rewrite it in a different language. User, translate this joke to Spanish. Why did the cheese go to the party alone? Because it felt blue, which is the output of the first one, of course, right? So then it's going to translate and give you an output. Yet another really cool example so that you can see exactly what's going on in your applications. It's even more useful though when you have even more going on. So let's just say that we do this example from last time where we invoke tools. We also do handing off. So one agent's autonomously handing off to another agent, which can then invoke a tool. There's a lot going on, right? And we already have a way of programmatically telling what's going on a little bit just by doing these handoff callbacks here, but tracing gives you a lot more detail as you can see. So let's check it out. So what I've done is I'm running this customer service agent, and I'm wrapping it with the trace. You don't technically have to because we're only invoking one agent, but the benefit of explicitly wrapping it with a trace is obviously it's more clear, but also you can give it a custom name. I changed the prompt to something a little more complex so that it actually does hand off to the manager and also calls the tool so that we can see in more detail how it's able to trace things. So now let's go check it out. All right, here it is. So we can see our customer service hotline has one handoff, one tool invocation. Let's click it. So we can see first we have our customer service agents. This is the initial prompt that we passed in. And you can see that based on that initial prompt from the user, it decided to do a function call, which is transferred to the manager. Like I told you before, agents, when you do a handoff to an agent, it's actually calling a tool behind the scenes. That's just how it works. So that's why it's a function call. And it's passing the information with an issue and why, because we told it explicitly to pass it in this format using the input type for the handoff. You can also see explicitly that there was a handoff. It logs that here. But then we can go to our manager and we can see that our manager was invoked. You can see that our manager has access to a function, the create ticket function. So it tells you that, which is really cool. It has GPT-4o, system instructions. It actually gets the full conversation history because these agents are working together. So when one agent transfers to another agent, it's useful to know what's actually happening. So it gives you the original prompt from the first agent along with the function call. So it essentially knows I was just transferred to based on this issue, right? So based on that, it decided to do a function call, which is create a ticket because it knows there's an issue with the website. So it should create a ticket to get our technical team to fix that. So it's smart enough to use the tool that it's able to use. So here's the actual create ticket log here. So function call, create ticket, and then here's the output that was given back to the large language model. So after a tool call happens, the large language model then decides again what to do. So it can either call a tool again or just respond. So now if you go to the last one here, we can see another call with our original system instructions, right? But then with our original user prompt, the function call, and then the new function call to create a ticket. So it basically has a full message history of what's going on. And then it's using all that information to give you a final response. I've created a support ticket to address this issue, ticket ID 12345, which is correct. And then our technical team will investigate it. So I really hope this all makes sense. This is tracing. This is just a way to see what the agents are actually doing behind the scenes. There are a couple of other things that you can pass into your trace function in the code, like a group ID and stuff like that, just some more advanced features. But this is generally how tracing works. It's a very, very useful feature. So yeah, hopefully you guys found this interesting as well. All right, guys, now I'm going to quickly show you guys how to do streaming with your agent applications. So if you go to ChatGPT right now and ask it something, you can see that as it's responding to you, the text is immediately coming in. It's not waiting until you get a full response and then showing it to you all at once. You can see that it's kind of showing you that it's thinking. It's not actually thinking, but it kind of looks like that. So it's a really cool effect that you'll see commonly with ChatGPT and other applications for large language models. We can actually do the same exact thing with agents as well. I highly recommend you check out the documentation for this. It's very useful, and we'll use actually these examples here to teach you how to do it. But besides this is just two different examples of how to do streaming, but you can also go to streaming events, and it gives you a more detailed list of all the different types of streaming that you can do. So just make sure to check that out, okay? All right, here's the first example of how to do streaming with agents. So just like always, you create your agent, and then now usually you do runner.run, but if you want to do streaming, you just simply do runner.run streamed. So this will give you a result that you can stream, and then you can actually listen to the stream events by doing for event and result.stream events. So the stream events function here will basically allow you to listen to the events as they come in. And then if you look in the documentation, there's actually three types of events that you can listen to. One of them is the raw response event. These are just the raw events that come from the large language model. And one of the events that you can listen to is the response text delta event. This is the actual text coming in from the model like we saw with ChatGPT. That's how that's getting streamed. So we want to listen to this specific event here. So again, we're just getting each event, we're checking to see if it's a raw response event type, and then we're making sure that the data of the event is of this type because there's different types of events that we can listen to, okay? But this is probably the most common one. So let's just run and see what we get. There we go. So as you can see, it's very fast. So you got to look very closely, but you can see that streaming it just like ChatGPT, right? Really cool. So what we're doing here is we're simply accessing, once we verify what it is, we're simply accessing events.data.delta. This is just the change or the new text that's coming in, and we're just printing it so that we can see it. That's literally it. So if you want to actually incorporate this into an actual application with your agents, all you got to do is listen to this just like we're doing here, but then add this to whatever string that you're going to be showing on the front end of your application if there is a front end or UI, okay? So that's one basic way you can do it. The other example is this. So you can also listen to different events, like I said, specifically the agent updated stream event whenever the agent is updated. and also whenever you run items like tools, like doing tool calls and stuff like that. So if we just run this, let's see what we get. So you see run starting, agent updated Joker, tool was called tool output 6, and then the message output itself, the completed message output. But of course, as you know, we can also listen to the raw response event to get the response text delta if you want that as well. So that's just more stuff that you can listen to if you want to figure out when tools are called and stuff like that and log it or whatever you want to do. It's pretty useful. Something that is pretty cool that I want to show you though is that we can make a very basic front end application to demonstrate this and make it look a little cool. So I'm going to make a new file in a folder called apps, called it streaming demo.py. It's a Python script, not a notebook. And for this, I'm going to be using something called a Streamlit application. Streamlit is just a Python library that you can use to build web applications really easily to quickly make demos, or just, it's just really easy. It's using Python. So here's the code. I'm not going to type it all out in front of you just because I think that would not be very useful. What I'll do first is just show you what the result is of this. And then I'll break down how the code actually works. I think that'll be useful because then you can just check the source code in the description below to see actually how this works if you want to stare at it. So to run this, I'm going to do another thing. I'm going to make a requirements.txt file. So in this, I'm going to do OpenAI Agents. I'm going to do python.env, which are the packages that I've already been using so far. I've just been manually installing them in the notebooks, but you could also do it like this to manage them better. And then we also want Streamlit. So now that you have that, you can then go to your terminal. We want to activate this environment, so the activate script. And now we could do pip install -r requirements. So that will install all 3 of those packages. 2 of them are already installed, of course, so it's going to install Streamlit now. Okay, all done. So now we can run it by doing Streamlit run, and then now we want the actual file, so we'll do apps and then Streamlit demo or streaming demo. Let's try it out. What this will do is automatically open up the app in a browser window, which is really cool. And here it is. So on the left side, you can see the configuration for the agent. So the agent name, the agent instructions, so a very basic one here. And then also you can choose the model as well, so you can see the differences between the models. I also have some quick prompts or just example prompts that you could load in just for fun. So yeah, what you can do then is, use the quick prompt, or you can edit this to be whatever you want and then click run. And you can see that streaming the response back. It's very fast, but it is doing it, as you can see. Let's try it again. Very, very cool, right? So we can swap it out for O3 Mini. That's a reasoning model that takes a little bit more time to think, but should still be very fast because this is a very easy task for it to do, I think. So you saw that it took a little more time to think about it, but overall it was still really fast. So that's just a demonstration of how you could create something like this, what it would look like if you put into an actual application. Let me now just break down the code for you a little bit so you can understand how I'm doing it. So at the very top here, we're just importing everything that we need, importing agents, we're setting the page config, so the page title, the page icon, layout wide, so basic information. Here we're going to have an actual title, we're going to write the text, see the streaming capabilities of OpenAI agents with visual effects. So we're going to have the sidebar. That's the configuration sidebar that I just showed you, where you can choose the model, choose some sample prompts, stuff like that. So you literally just create text inputs, text areas. It's really easy using Streamlit text box, or select box rather, for drop downs. It's really incredible how easy it is. So that's for the sidebar. And then after that, you have the actual part where you can input your message. So you're doing a user input. It's a text area, which is just a large text input with this, and then it says demo prompt. So whatever prompt you choose will be put into that. And then you have a send button, so it literally says send. Very easy so far. We'll come back to this in a second, but that's actually running the agent. But after that, we then have it so that if the send button is clicked, that's what this is saying. If the send button gets clicked and there's something in the user input, then we're going to create an agent with the settings that we specified before. And then we're going to show a little spinning icon, a little loading icon, and actually run it using this function above. And then after that, you have a clear button that just lets you clear the response if you want to, okay? So taking a look at the function above, it's an async function because we're streaming, so it's async. We're simply doing runner.runStreamed as we learned about before, passing the input and the agent, and then we're listening to those stream events as they come in using this for events loop here. So result.stream events, for events, we're checking to see if it's a raw response event and if it's a response text delta event type in terms of the actual data of the event. And then if it is, we're just going to print out the text data just to log it. And then we're going to add it to our response. This response part variable here just is the actual response that will be showing on the front end. So we're updating it, and we're just appending it because it only gives you the new input, right? So as the model is quote unquote thinking, it's giving you the new input as it comes in. So you just add it essentially, okay? And this is just a little trick you can do for a little cursor effect as it's, going through the quote unquote thinking process. Hopefully I didn't speed through that too fast. I really hope that made sense. But again, check the description for the actual code for it so you can view it yourself. But yeah, it's actually incredible how easy all of this is. Hopefully you guys agree. So that is how you do streaming with OpenAI agents. Alright guys, now we're going to talk about a really cool concept called Guardrails. Guardrails is a feature within the Agents SDK that allows you to validate the input and the output of an agent to ensure proper usage. So basically the way it works is if you have an agent and you want to have an input guardrail on that agent, every single time you feed an input to that agent to invoke it, is checked first by a function, the guardrail function. And this function can be anything, literally any code that you want to run. So you could search for a certain word or key phrase that you don't want to be allowed, or you can actually have another large language model or another agent that is dumber, that's cheaper, that runs and checks to see some criteria that you don't want. So as a more concrete example, if we want to have a study helper agent that assists users in studying by explaining concepts or providing guidance without directly solving homework or test questions, this agent can be used obviously by a user, but maybe we don't want them to be able to cheat. Like we would want to detect if they're just providing the homework questions directly. We don't want to give them answers. We want to actually help them study and understand concepts so that they can do the homework themselves, right? So what you can do is add a guardrail for that. So input guardrails. This is a list because you can have multiple of them. I mean, a guardrail is actually just a function. So we're going to do async definition cheat detection guardrail. Now the input for a guardrail is a little complex. You just have to provide a lot of information. So I'm just going to go ahead and copy and paste it from the documentation. So we'll do this. So it requires a context, which is the context of the agent. We'll talk about context in a little bit. We'll have the agent itself, and then we'll have the input of the agent. So this can be either a string or a list of messages, okay? And now the return type of this function will simply be a guardrail function output. So we'll just make sure to import that. All right, so like I said before, the implementation of the function can literally just be any code that you want as long as it returns the guardrail function output. So guardrail function output, and you want to provide this two things. You can do output info. So it's just going to be any information that you want the original agent that is using the guardrail to have to know what the guardrail did essentially. So just extra information to put it simply. But the most important thing is this boolean here, tripwire triggered. The tripwire is essentially meaning that something that you don't want to happen happened. So let's just say that we detected a word that we don't like, then we return true. If the guardrail does not detect anything that we're trying to prevent, then you just return false. That's all that means, okay? So if we want to have an input guardrail that detects if the user is trying to input their actual homework questions, I'm sure you could come up with some sort of algorithm that can detect something like that, but this is the perfect use case for an actual large language model. So we can have a second agent that does that. So the homework cheat guardrail agent. So the purpose of this agent is to detect if a piece of text is part of a homework or not. So the name is homework cheat detector, and the instructions are determine if the user's query resembles a typical homework assignment or exam question, indicating an attempt to cheat. General questions about concepts are acceptable. And then I gave it some examples. This is common when you're making a prompt so it performs better. So cheating, fill in the blank, the capital of France is blank. So fill in the blank questions are obviously directly taken from someone's homework. We don't want to allow that, so that's cheating. Another example is this, a multiple choice question. So which of the following best describes photosynthesis? A, B, C, D. But we want to allow non-cheating questions, like very broad questions so that the user can understand concepts, like what is the capital of France or explain photosynthesis. Those are not cheating in our book, okay? So for this guardrail agent, we obviously want a more deterministic output. So we could set the output type to a boolean if we want to, if we just wanted to return true or false. But if we want it to be a little more detailed, we can have a homework cheat detection output that returns attempting to cheat the boolean itself, but also an explanation. Models actually perform better if they have to explain their reasoning. So forcing it to provide an explanation, because this is not optional, along with the actual boolean that we need, is a good way to do this. So we're going to copy this type here and set it as the output type. So now back in the guardrail, when we invoke this, so we can do detection result is equal to await runner dot run homework cheat guardrail agent. So this is the input of the original agent being essentially rerouted into this guardrail agent, which then gives us an output that we can use in our guardrail function output. But first, let me import this real quick. So first we'll do tripwire trigger. This is the most important one. So for this, we'll do detection result dot final output. So we know that the final output is going to be of this type. So we just need to access this field here. So attempting to cheat. So the tripwire is triggered if it's an attempt to cheat. Pretty simple. And then for output info, this is just, like I said before, extra information, optional information about the guardrail's output. For example, the guardrail could include information about the checks it performed or granular results. So we're just going to return the full output from our guardrail agent, which includes the explanation. The explanation would be useful. So I really hope this is making sense. So what I want to do now is just copy the guardrail function and provide it to this here. And we also want to add to this input guardrail. All right, so let me just give you a recap real quick of what this is doing. So we have our study helper agent. This has an input guardrail. So the way it works is every single time you invoke this agent here, the input will be first routed to this cheat detection guardrail function, which in this case will route to a sub agent that we created called the homework cheat guardrail agent, which checks to see if the input that was provided is from a typical homework question, so like a fill in the blank question or a multiple choice question, because we want to determine if they're trying to cheat or not. We don't want them to answer homework questions directly. So return true or false if it's attempting to cheat, as well as an explanation for why you think that is. So that's what this agent will do. So the tripwire will be triggered depending on if they're trying to cheat or not, as well as provide some extra information. And so back in this original agent that was originally invoked, whenever it gets that guardrail function output, it will actually throw an exception if the tripwire was triggered, so that we cannot continue invoking the agent. It won't actually invoke a response because there's no need to. The tripwire was tricked. So let's actually invoke it now. So we have this piece of code here. This is the particular exception that will be thrown if the tripwire is triggered. So we're just going to listen for that and detect if it actually happens. We're going to test this first with an input that is clearly an attempt to cheat. So fill in the blank. The process of converting light energy into chemical energy is called blank. There we go. So homework cheat guardrail triggered. It was able to catch the exception here because the guardrail was obviously triggered. So if we now do an example that is clearly not an attempt to cheat, it's just asking something about the Civil War, this should be fine. There we go, it did not trigger, so it didn't actually throw an exception. So we got our actual response. The main causes of the American Civil War include slavery, blah, blah, blah. So it was able to pass the guardrail, and it went on to actually invoke the original agent to get a actual response from it, okay? So here's our trace in case you're interested. So first we go to our study helper agent, and then it immediately routes to our cheat detection guardrail, which shows that it's working. And then it shows actually response from this if it's triggered or not, which is false. So it's not triggered. So it goes then to our homework cheat detector sub agent, which returns an output type of this. Here's it actually being invoked. So here's the system instructions. The query that was originally given to the original agent is being routed to the sub agent here, and it returns this. So attempting to cheat, false, and then the reasoning is the question asks for an explanation of a historical event, which is a general inquiry about concepts. So that's exactly what we want. That's doing perfect. So now since the guardrail did not trigger, it's going to go back to the original agent and get a response, and here it is. So these are really good for, one, making sure that the agents are used for what they're intended. So if you're trying to help people learn how to do their homework and not actually help them cheat, this is a good way of preventing that. But also, if you have an application deployed that uses agents, you don't want people to just randomly use your agents for whatever they want, expending your tokens and your money on things that you don't want them to be able to use it on. So this is a good way to prevent that. One other thing I'll add real quick is that for these sub-agents here, we are, of course, expending tokens running this sub-agent because, it does have to take the original input and check it again against another set of instructions. That is another LLM call. So since these are so narrowly focused on something so specific, what you can do is just set this to be a dumber model. So you could set it to I don't know, for example, the original agent could be GPT-4o, but this one could be GPT-4o mini, which is a dumber model, a faster model, but also a way less expensive model. So that's something that you can do to save money as well, okay? Now, we just saw how input guardrails are super helpful. Of course, there's also output guardrails. So this is validating the output of our model to make sure that our model does not output anything that we don't deem valid. So just making sure that our agent is not saying anything crazy or literally whatever you want to check. So it works essentially the same exact way. So you have an output guardrails list that you can provide to your agents. So we have our forbidden words guardrail. So this is simply a function that is annotated with output guardrail. It takes in the same information, the context, the agent, and the output, because of course we're validating the output of the agent, not the input of the original invocation. So this output guardrail is very simple. It's just going to check to see if the output of this agent here contains certain words like fart, booger, or silly goose. So when it's invoked, we're going to convert the output to lowercase. We're going to check to see if any of those phrases that we don't like are in the output, and then just keep track of which ones we found. So at the end here, we're going to return our guardrail function output. So this will be dependent on if we found one of our phrases or not. And then we'll provide other output information like the reason. So output contains forbidden phrases and forbidden phrases found, the actual list of forbidden phrases that may be useful, okay? So I really hope that makes sense. I think it's a pretty simple concept. So before, with our input guardrail, it runs before the agent gets our input, but this one runs after our agent has provided an output. We're just validating the output to make sure it's valid, right? So we're going to invoke our agent to say the word fart. So if it says the word fart, that's not going to obviously pass the guardrail, so we'll be able to validate that. There we go. So it says found forbidden phrases fart. The agent said a bad word. He is fired. So pretty simple. And then if we say something obviously not invoking that, it won't trigger the guardrail. So, all right, that's it for guardrails. That's input guardrails and output guardrails for agents. It's a really cool way to validate the input and the output of an agent to ensure that's being used properly. So hopefully you guys found this interesting. All right, I'm going to show you guys now how to do multi-turn conversations with agents and also maintaining the last agent that was invoked. So currently with what we've learned up to this point, we can only really invoke an agent once and get a single response back. But in our experience using ChatGPT and other stuff, of course, we're having conversations with these agents, or rather the large language models behind them. So I'll be showing you guys how you can actually set it up so you can actually have a conversation with an agent rather than just a one-off message and response. That's not very useful, right? So the cool thing about result is that it gives you more information than just the final output. The final output's just, as it says, the output of the last agent, so just the simple agent. But we can also do functions like toInputList, which will give us the full conversation history of the agent. So it says creates a new input list, merging the original input with all the new items generated. So all that means is that you get a full list of all the messages inside of the chat. So what I'll do is just print it out, each message. So for message in result.toInputList will just print out each message to see what this gives us. Let's try it again. There we go. So we can see that we get the original message, hey, and then it's the role of user. So that's me invoking it. And then now we get the actual response from the large language model, which has a little bit of more information, but the thing that stays the same is the role and the content. So if we scroll down, the role is assistant, because that's just the large language model. And then we have content. It's not exactly a string. It has a list within it with an object inside of it, but here's the text. Hi there, how can I assist you today? So a lot of this is abstracted for you when you just print out the final output. But if you want the actual full conversation history, this is one way to work with it. So now that we understand what the conversation history kind of looks like when we output it, we can actually provide an initial conversation history to the model when we first invoke it, as if there's already a chat that happened. So let me just show you what I mean. So we're going to do combo, which is a list, and then each item of the list is going to be of the type T response input item, which we're just going to import above T response input item. And then each element of this list will be a single message in the conversation by one of the users. So we could do, for example, our initial message saying, hey, and this is going to be by the user. And then we can have the next message by the assistant that says, hey, how are you? How can I help you today? With the role of assistant. So basically what I'm trying to show you here is that we can manually create this conversation in the same format that it was outputted as. So we could take this conversation and just simply replace our string here that we were doing before with the actual conversation. So this run function accepts both a string as our input or a list of the T-response input item. So that's why we're doing this. And you can add as many messages as you want. So now let's run it and see what we get. There we go, so it worked. So we could see that, hey, role user, hey, how are you? How can I help you today? Role assistant, which is what we told it to have originally. And then finally, we get the actual response from the large language model. Hey, how's it going? What can I do for you today? And this is also from the assistant. So we have two assistant messages in a row, but it doesn't really care. It's just kind of predicting what it would say next. So if you want to, you can add as many messages to this as you want. So we could say content, I'm having a bad day. Role user. So you can say something like this, I'm having a bad day, and we can invoke it and get a response. So this is going to be very useful when you want to provide a conversation history to an agent when you invoke it. But we want to make it so that you can have a back and forth conversation, right? So we're going to copy this and move it down. So we'll start by getting rid of all of this and just leave it empty. We'll get rid of this as well. What we're going to do is move this into a while loop. So while true, a infinite while loop. So while true, and we're going to invoke it with the conversation history. And then we'll print this message here. This will make more sense when I finish typing it all out. But so now we're going to have user input is equal to input view. So we're getting input from our console from the user, and we're going to use that to add onto our conversation. So combo.append, and we're going to append the new message. So content, and we're going to say user input. So we're essentially crafting the message manually and adding it to our conversation history so that we can invoke our agent using that conversation history. So now that we have the modified combo, we can then pass it in like we're already doing here. We get the result, and then we can print the response from the agent, same way we always do, so get the final output. But then, importantly, before we loop again, before we do the next iteration of the loop, we want to replace the entire conversation with the new updated information of the full conversation history by doing convo is equal to result.toInputList. Because as we learned above when I took the time to show you this, toInputList gives you the actual conversation, which is the same as this. So we could simply replace our convo with the full conversation history that this returns for us. So let me run this and I'll explain it again in a second. So you are now chatting with Agent Bob, type exit to in the conversation. So we can see that we can input something at the top here. So we could say, hey, and then it says, hi there, how can I assist you today? What was my first message? It says your first message was hey. So it does have a history of conversation that it's using. So we're having a back and forth conversation now. It's not resetting every single time. Pretty cool, right? And then we can exit if we want to. But of course, we have not implemented that. So the way that you can implement the exit feature is after you get the user input, you simply check to see if the user input is equal to exit, and then if it is, you break it out of the loop. Okay, so besides having a multi-turn conversation, since we're using an agents framework, we also need a way to maintain what agent we last sent a message to. Because if we have a setup like this where we have our triage agent and this hands off to our math tutor agent or our history agent, if we were to invoke this triage agent and send a message like, hey, can you help me understand this history stuff? It would obviously hand me off to the history tutor agent. The history tutor agent would then give me a response and then it would end there. So if we do what we did above to have it so I can have a back and forth conversation, the next time I send a message, it won't go back to the history tutor agent, it'll go back to the original agent, which doesn't make a lot of sense. So we just simply want to modify this so that I can also keep track of the last agent that was handed off to. So what I'll do is I'll just copy it and I'll move it down here. So up here, when we're keeping track of the combo, we can also keep track of last agent is equal to, and since the loop has not started yet, we'll simply start it with our triage agents. That's who we want to start with, right? And then down here in our, when we actually run the agent, we can then do last agent. So it always uses the last agent. So now we just simply need a way to actually update the last agent to whatever the last agent is. And what's great is that just like everything, the Agents SDK makes it really easy. We can do last agent is equal to result.lastAgent. So it already keeps track of it for us. So now what I'll do is instead of just printing agent and then the output, we'll have it print actually what agent you're talking to. So that's a more clear way of knowing what's happening. So I'll replace this with this here. So we can do lastAgent.name and then the final output. We also need to make sure we move it below the update because of course if we have it before we update it, it won't show the proper agent. So I'll say, hey, so it says triage agent because I'm still in the triage agent. It has not handed me off because I have not indicated I want to do any math or history. So if I say something like, help me learn how to divide, it should route me to that. So handing off to the math tutor agent. Boom, it says math tutor, of course. Let's go through the basics of division. And then it tells me how to divide. So I can keep sending messages like, thanks. And I'll get a new response. So I said, thanks, math tutor, you're welcome, blah, blah, blah. So it's working perfectly. It's able to keep track of the agent, the last agent I talked to. That way I can have a back and forth conversation with a multi-agent system, not just a single agent at a time. So hopefully you guys find this interesting as well. I'll also leave the simple script in the source code so you can check it out yourself. This is a simple Streamlit application similar to what we did before. The difference is that this one allows you to have a conversation with an agent, so a back and forth conversation. So if you want to run it, we're going to go to our terminal. We're going to activate our Python environment. Then we're going to navigate to apps. And then to run it, we're going to do Streamlit, run simple chat. That's going to open up a browser for us so we can check it out. It's in light theme, don't yell at me. So we can chat with ChatGPT 4.0. We could say, do you love me? How about that? There we go. So I'm here to help you with anything you need. What can I assist you with today? What did you say was my first message? So as you can see, it's able to keep track of the conversation history. So it's just a cool little app that you can make. It's very simple. It's not very complex, but it's a cool thing to take a look at. All right, guys, in this part, I'm going to talk about context, which is simply a way to pass along data and other dependencies when you're calling the agents. You may have noticed in the previous parts, whenever I do stuff like guardrails, or handoffs, or tool invocations like tool calling, the functions are required to have a context passed in as the first parameter usually. So up to this point, we've been doing run context wrapper with none as the subtype. So that is what we'll be learning how to use today. So the purpose of a context is, again, like I said, to pass along data. So first, you're going to define the data that you want to pass along. So this will be a user profile class that has an ID for the profile, a name, and then also a shopping cart. So the idea is whenever you call your agent, you're going to pass this user profile, an instance of it with these values filled out. to the agent so that every time we call a function like a tool or a guardrail or anything like that, the function will have access to our user profile. So this is a very important note. The large language model for the agent does not have access to the context. This is purely for our functions, for our code to use as we're running through the agent process. We're going to make a very simple agent application that allows you to plan a shopping list, so I guess a grocery list, and the agent's going to have access to a bunch of tools. Like, for example, you may want the agent to be able to get the user's budget, so maybe access their bank account or something like that. We're just making it up. So we're going to define a function called getBudget that we will make available to the agent. And like I said before, every single function that is part of the agent, such as a tool call function, will have a wrapper, a context wrapper. So run context wrapper, which we then import from agents, right? And instead of doing none, now we just replace that with our user profile context type that we created. So now every single time we call this getBudget function, or rather the agent calls it, we will have access to the data in the user profile that we pass in when calling the agent, okay? So for example, if we want this function to get the account balance of the user using the user's ID and their linked bank account. So for example, something that we can do with this is that since the wrapper, if you do wrapper.context, the context here is returning the actual user profile type, this here. So since it has access to that, we could, for example, use the user's ID to call out to a third-party API to get their budget, like their bank account balance or something like that. That's probably an extreme example, but that's something you could do with that. So we're just going to print out getting account balance so we know when it's called, and then we're going to extract the user's ID by doing user ID is equal to wrapper.context.id. So we're accessing the ID from the user profile. And then now at this point, we're just going to pretend we're fetching the account balance from a database using the ID. We're not actually going to do that. Just keep it simple. We're just going to return $100. So the user has $100 in their budget that we can use for our agent. Okay, here's some more examples. I'll go through them one by one. We're going to have another function tool, search for item. So the agent is going to pass in an item as a string. So like, I don't know, pasta. So it's going to be pretending to search for that item in a database on like a grocery website or something like that. And then it returns the item and the price. So it's just going to make up a price. But of course, that would actually get a real price. So this is what the agent will use to find items for the user's recipe to see if it's within the budget, right? So that's search for item. Then we have get shopping cart. This will use the passed in context to get the user's shopping cart. So it simply does wrapper.context.shopping cart, return that, which is just a list of strings. So it returns that to the agent to use. But then we also have add to shopping cart. So the agent will pass in a list of items, item strings, and those will be added to the user's shopping cart context. So yes, the context can be used to pass data along the agent process, but it can also be modified for whatever you want to use it for. So we're adding onto the shopping cart as the agent does its thing. So later on, when we call purchase items, we could again use our context to get all of the items in our shopping cart and pretend to purchase them. I really hope that makes sense. So it's worth emphasizing the agent does not have access to the user profile context that we're passing along here, but the functions do, okay? So finally, we can create a shopping agent. So we're going to do shopping agent is equal to agent, and then you define all the regular stuff that you defined before, so the name and the instructions and the tools and stuff like that. So I'll paste it. There we go. The difference though is since we're now using a context with the agent, you can also do this. So you just provide user profile, which is our context type that we created. So now when you create your agent, you also specify this user profile subtype here that will be used for the context. So now finally, when we invoke the agent, so we can do runner.run shopping agent and then say, hey, we also want to pass in that context, which is the user profile. So we can do context is equal to. So I'll simply say profile is equal to user profile, ID 123, name Alex, shopping cart is empty initially. So then we just pass it in, and that's it. All right, let's invoke it now. So we say, hello, how can I assist you with your shopping today? So it's working. It did not call any functions just because we haven't really had a conversation with it yet. So what I'll do is make it so that we can have a back and forth conversation. So this code will be familiar. So we're just looping over and over, asking for the user's input. If they type exit, we'll exit. Otherwise, we're going to add to the conversation and then invoke the agent with our conversation items and then also our context that we now have, okay? So let's try it out. So we're going to say, hey, can you help me put together a shopping list? It says getting account balance. So it did call the account or get budget function. So it used that wrapper and pretended and everything like that. And it gave us a budget and then gave the agent the budget. So it says shopping assistant, your budget is $100. What items would you like to include on your shopping list, or would you like some suggestions? I'm looking to make some spaghetti tonight. So with that, it should, already know. Here we go. So shopping assistant, great choice. Here are some common ingredients for spaghetti. It gives me all the ingredients. Would you like me to add these to your shopping cart? Do you have specific items in mind? Yeah, let's add them. So what it did is it first searched for all the items before adding them to my shopping cart, because the agent is smart enough to understand that it needs to know the price before adding it to my shopping cart so I don't go over budget. The whole purpose is to not go over budget. So it tells me with everything added up, it does go over my $100 budget. The prices are not real at all, $85 for pasta, but it's working, as you can see, very well actually. So the agent is doing its job. Let's just tell it, help me narrow this down to make it more affordable. So it says, here's a more budget-friendly list, blah, blah, blah. The total is 134, still over budget. I'll just use some pepper for dinner. How about that? Okay, so I told it to add the pepper to my cart and purchase it, so I added them to my shopping cart with the add shopping cart function, and then also called the purchase items function, and it successfully purchased my pepper. So I'm gonna eat some pepper for dinner. Awesome. Very low in calories. Our agent is working exactly as we wanted to. It's helping plan a grocery list using our budget, so it's actually a pretty useful agent, I would say. You just have to hook it up with actual databases and stuff like that. But the most important thing, of course, is that you can see how the wrapper is useful here. It's able to access data, modify data, like add to our shopping cart, so that later on when we do like purchase items, it has direct access to that shopping cart and can just, purchase them. So you can do all kinds of stuff with this, whatever you can fit inside of this, class here. So it's up to your imagination. But I'll just give you guys one more example of why a context is useful. So before I showed you guys that with guardrails also have a function to find, right? The cheat detection guardrail from last time. So this is our study helper agent that has a cheat detection guardrail that will detect if you're trying to cheat or not. So we already know about that from before. So I modified this a little bit so that the cheat detection guardrail function also accepts a context type of user profile. So we can see the definition up here. This one has an ID, a name, and if they're admin or not. So the way that this will work is every time the guardrail is triggered to detect if it's, trying to cheat or not, if the user profile admin boolean is true, meaning that they're an admin, we're going to bypass the guardrail. So they're allowed to cheat if they want to. So if they're an admin, we'll just return tripwire triggered false, and then also an explanation of admin bypass. So when we invoke the agent, we're going to pass in that context, the user profile with some basic data. So since they're admin, but they are trying to cheat, it's going to allow them to bypass, and we don't get an exception, so it didn't trigger the guardrail, so it gave us an answer. But of course, if I make this false, it will be triggered since I'm no longer an admin. So something else kind of interesting is that if you call any other agents, you can pass along that same context, so context.context, pass it along. So now this other agent, the sub-agent here, will also have access to the context as well if you want to do anything with it for that one as well, okay? I want to show you guys now how to visualize your agents. There's actually a really cool tool that the OpenAI Agents SDK hooks into so that you can basically create a flowchart for your agents. So first of all, you need to this is all on their documentation, by the way, but first of all, you need to install this package here, so OpenAI Agents, but also this is specifying the viz dependency, so this will install both if they're not already installed, of course. Once you have that installed, you still need to also install graph viz separately. At least I had to, because when I tried running the code that the OpenAI docs provides, it did not work because it did not detect the path. So basically all you got to do is come here, it'll take you to this here, and then you just select what operating system you're using. I use Windows, so just find the 64-bit exe installer and then install it. Make sure that when you're installing it, you select the option that allows you to add it to your path. That will just make sure that you can actually run it and you won't run into issues. After that, I tried a bunch of things. I could not get it to work still, so I just restarted my computer, and it worked after that because of the path change. So you may not run into that issue after downloading and installing it, but I did, so that's just an extra step that you can do if you run into issues, okay? But once you have it installed, now you can really easily visualize your agents. So I'm just going to go to one of my previous tutorials here. So we'll do this one here where we have 3 agents. We have our triage agent, and then we have our history tutor agent and our math tutor agent. And now literally all you have to do is just do agents.extensions.visualization import draw graph, and then down here we can call draw graph, and we're just simply going to pass in our entry point agent, our triage agent, and watch this. Look at that, we got a cool little diagram, a flowchart. So at the start, it first goes to our triage agent, of course, and then from there it can go to our history tutor or our math tutor. What's cool about this, though, is that it actually also shows the tools that are available to the agent as well. So if we were to add a simple tool to our history agent, so we'll do function tool, and we say define print something, literally just whatever, right, of course. So we're going to say print blah blah. So here's our tool, and then once you have it, you can simply add it to your whatever agent you want. So we'll do tools is equal to print something. So now if we run this again, So for some reason, it only works when the tool is on the original agent. I don't know why. Maybe that's a glitch or something they need to add. But I tried adding it to the history agent. It did not show up. But yeah, if you add a tool to the original agent here, it will work. Okay. And yeah, the downside of this is that, of course, if there's no handoffs, if you just have a deterministic setup where you just run one agent and then use that output to run another agent, of course, it won't show up in the flowchart because there's no connection set up between the agents, so it can't really visualize that. So if you have a setup more like this, it's a pretty useful tool. So give it a try. It's pretty cool. Okay, guys, I just wanted to take the time to show you some of this documentation here on common agentic patterns. This is directly from the OpenAI Agents GitHub here. If you got to this point and you haven't checked out the GitHub, make sure you do that. It has a lot of really, really good examples. But yeah, anyway, I just want to go through this documentation because it's really good. It's no point in me just doing it from scratch. We're just going to go through some of these code files here and just go over the different ways that you can configure your agentic applications. So the first one is a deterministic flow. This is the very first thing I showed you, where if we have multiple agents, we're not connecting them through handoffs. We're just connecting them by taking the output of the first agent after running it and using that to inform the input of the second agent and however many agents you want to have. That's why it's called deterministic, since you have manual control over what agents are executed and when. You kind of know exactly what's going to happen. So this example demonstrates a deterministic flow where each step is performed by an agent. The first agent generates a story outline. We feed the outline into the second agent, and the second agent checks if the outline is good quality and if it's a sci-fi story. If the outline is not good quality or not a sci-fi story, we stop here. If the outline is good quality and a sci-fi story, we feed the outline into the third agent. So when we start the program, we start by running our story outline agent, which is just creating an outline of a very short story based on the user's input. So we ask the user what kind of story they want to make. We use that to create an outline, right? And then we feed that outline result into the second agent, which checks it as it said. So the second agent will read the given story outline and judge the quality, also to determine if it's a sci-fi story. So the way it's going to output that is by having an output type, which is another great way of having a deterministic flow of things, because since the output has to be of this type, we know exactly what to expect every single time. If, for example, you didn't have this, you would just get a string and you would have to hope or beg in the prompt for it to output it in this format of, this and this. So good quality bool and is sci-fi boolean. So based on that output, we determine if we want to go to the final agent, which is just actually writing the story using the outline result from the first agent. So yeah, hopefully that all makes sense. That's a deterministic pattern. This is great if you want a predictable flow of things. There's nothing wrong with using that. But if you want to, you can do more advanced stuff, which is handoffs and routing. This is essentially doing what we learned before, which is connecting agents together using handoffs and giving the router agent the capability of autonomously deciding whether it wants to route or not to a different agent. So it's a more automatic way of doing things. It's not deterministic because you don't exactly know what's going to happen every time, okay? So in this example here, we have 4 different agents. The last one here is the triage agent. This one is deciding which one to hand off to. So based on the language of the request, we route to different language agents, so French, Spanish, and English. So what makes this not autonomous, of course, like I just said, is the fact that the triage agent has to decide on its own what agent to route it to depending on the language. It has full control over what it wants to do, essentially. And the rest of this is just having a back and forth conversation with the agent after it's decided which one it wants to route to. So pretty cool. Another cool thing that you can do is use agents as tools. So the mental model for handoffs is that the new agent takes over. It sees the previous conversation history and owns the conversation from that point onwards. So what that means is that if you ever look at the traces for when you're doing the routing or the handoffs that we've done before, whenever it hands off to the next agent, the agent doesn't return back to the previous agent. It gets inherited all the conversation history of all the previous agents and then just takes over from there, okay? So however, though, you can use an agent as a tool because as we know, if you've ever seen a trace for a tool, whenever an agent calls a tool, it returns back the value from the tool to the agent to do whatever it wants with that information. We can use an agent as a tool so that the tool agent goes off and runs on its own and then returns back to the original agent. So for example, you can model the translation task above as tool calls instead. Rather than handing over to the language specific agent, you could call the agent as a tool and then use the result in the next step. This enables things like translating multiple languages at once. So let's check it out. And if you guys find this video helpful, please let me know. Just going over code like this, I just want to be as helpful as possible. Okay, so we have our three agents same as before: Spanish, French, and Italian. They all look the same. These are all the same, but then we have now an orchestrator agent. So this one has instructions. You are a translation agent. You can use the tools given to you to translate. So as you can see here, we have all the tools here, but no handoffs because we're doing the handoffs as tools. So for example, we're doing Spanish agent as tool, and then we're doing translate to Spanish, that's the name of the tool, and then the description so it knows what to use it for, translate the user's message to Spanish. So essentially, again, we're just taking every single sub agent that we would normally hand off to and using it as a tool instead so that every time it effectively hands off to these agents, it actually returns rather than giving them full control. So it gives us the capability, if asked for multiple translations, you can call the relevant tools in order. Because as you know, when you're running an agent can actually call multiple tools or call the same tool multiple times before returning the final output. So it can do the same thing with this. If we have multiple languages that need translating, we could simply call multiple agents. So that's a really cool concept to play with for sure. Okay, now we have LLM as a judge. This is a really cool concept that you can use to improve the quality of an output. So large language models can often improve the quality of their output if given feedback. So a common pattern is to generate a response using a model and then use a second model to provide feedback. You can even use a small model for the initial generation and a larger model for the feedback to optimize cost. So, for example, you could use a large language model to generate an outline for a story, or an agent rather, and then use a second agent to evaluate the outline and provide feedback. You can then use the feedback to improve the outline or repeat until the large language model is satisfied with the outline. In other words, you can basically have one agent that produces an output, and then you can have a second agent that evaluates the output, and it decides on its own, is this good enough? If it's not good enough, it'll return back to the previous agent with feedback so that it could try again, and then it'll send it back to the evaluator agent to see if it's happy with the changes, and it can repeat that process for as many times as you want. You can even add a cap to it so it doesn't go on for too long. We're actually going to do a similar flow to this in our final project video, so stay tuned for that. But looking at the example here, we can see that we have our story outline generator, same as before. So you generate a very short story outline based on the user's input. If there is any feedback provided, use it to improve the outline. So here's the evaluator agent. So it's an agent. You evaluate a story outline and decide if it's good enough. If it's not good enough, you provide feedback on what needs to be improved. Never give it a pass on the first try. So you're telling it that it has to give feedback on the first try to make it as useful as possible. So we're going to return a specific type for this that has a feedback. So the actual string of the feedback that the first model can use to improve its outline. And then the second part is the score, which is pass, needs improvement, or fail, which we can then use to determine whether to go into the next part or not. Okay, so let's take a look at how that's implemented. So we're asking what kind of story do you want? We're feeding the story into our outline generator. And then basically what we're doing is we're taking the output of the outline from the outline generator and feeding it into the evaluator agent. And then we're taking the output from the evaluator agent and determining if it passed or not. So this is a deterministic flow in a sense. We're going to take the output, determine if it's pass. If it's pass, we're going to break the loop, and there's our story. It's good enough. If it did not pass, what we're going to do, this is kind of a cool trick you can do. Instead of having it re-invoke the story outline agent in a different way, what it's going to do is actually add on to the conversation history that we're going to feed into the outline generator. So we're going to add a message that says content and then the actual feedback from the evaluator agent. So basically for the next iteration of this loop, we're going to generate an outline again, same as before, except that we're going to have the original story that it wants to create along with the feedback that was generated by the evaluator. And it's just going to repeat that process over and over and over until the evaluator is satisfied. So I hope that wasn't too confusing, but that's pretty much all I'm going to show you. You also have one called parallelization and guardrails. We went over guardrails, and then you can look into parallelization if you want to, but these are the main ones that I really wanted to show you guys because now that you got this far in the series, you guys know how to make, all kinds of agents and stuff like that, but actually knowing how to build a flow or use common agentic patterns will actually make it so you can make these applications and not be confused on how to do stuff, right? So in this part, we're going to do the final project of the series. We're now going to do a project so we can take everything that we've learned and sort of compile it together and see if we can make something cool with it. We're going to be making a deep research tool. So you may have seen something like this when you're using ChatGPT or Grok or Gemini. They all have a tool like this or similar to this, where basically you ask a question and then it goes off and does a bunch of deep research for you, which means that it searches websites and thinks through it a little bit more than it would if you just ask it, using the regular, ChatGPT feature, right? I think it's a great example that we can build ourselves because one, you can have a really cool tool that you can use to do research on your own. And two, I just think it's a really great project because we can see how agents can work together to achieve a goal. We can give them tools and stuff like that as well. So overall, this is going to be a great end to the series, I believe, because this is going to allow you to take everything that you learned and put it into practice. All right. So first of all, let me just show you the inspiration for what we're building here, and then I'll show you what we actually are going to be building. So if you go to Grok, this is one of my favorite ones. If you ask a question and then enable deep research, it will go off and search it for you. So first it'll think through what it needs to search. So searching for is water good for you, and then it gets a bunch of websites. And then after that, it will go through each of those websites one by one and then compile the results and then do more searching and more digging until it comes up with a final result for you. And it just tells you a full, basically, research report that you can look at. So it's a really cool one. Google actually has a really more, I think, a detailed one. You can ask it a question, then it puts together for you a research plan. So it's very detailed. So it actually breaks it up into before it even starts. So research websites using all these queries here, and then analyze the results and then create a report. We're going to do something very similar to that. So let's click start, and you can see it. It's really cool. It shows you the thinking process as it's doing it, the researching process. So you can see it's kind of thinking through it. And then it's going to start looking through websites. Very similar to how Grok just did it. So look, it's going through all these websites here. Very cool. Also, yeah, I know the query's messed up here because I was originally just going to search is water good for you, but then I was like, that's a little too easy. So I did look into the effects of fluoride in drinking water. But luckily, he was able to interpret that. So it's going to be looking for is water good for you and the effects of fluoride in drinking water. So it's really smart. Okay, it finally finished after a couple minutes, and I got a full research report here telling me the effects of fluoride in drinking water. So I can read through that. So down here at the bottom, it gives you the full sources. So it's very, very, very detailed. Very cool, right? So let me show you guys now what we're going to be creating ourselves in this video. So originally I had it as a front-end application. So I basically had a Python backend and it did all the stuff that we're going to do. And then I connected that to an Angular application front-end and it looks really, really snazzy and everything like that. But it's a little too much just for this episode, having to figure out the whole Angular part and connect them together using WebSockets. It's just a lot of stuff that I don't feel is necessary for you guys when you're trying to learn about how to do agents. So we're going to keep it simple. I'll have the source code for that if you do want to look at it, if you're curious, but we're going to keep it simple. We're just going to have a basic Python application as we've always been doing, and it's going to run in the terminal. So it's still going to look really cool, as you'll see. So that'll just be in the terminal though. So to run it, we can do Python main. So it says this tool performs in-depth research on any topic using AI agents. What would you like to research? We'll do the same query. Is fluoride in drinking water good for you? So as soon as I ask this, it's going to happen really fast, so try not to miss it. It's going to start researching that original query. It's going to first break that up into subqueries. So we have 3 subqueries: health benefits of fluoride in drinking water. And what it will do is one by one search for websites with these subqueries here, just like Google and Grok did. So it's going to find a bunch of websites that match this subquery and then go through each website, scrape them, and come up with a summary. So here we go. We have the research results for this. So for each query, we have a source. So it found a website and then also generated a summary of the findings on that website. Right now for this basic demo here, I limited to just one website per query, but you can literally make that however many you want. You can make it as detailed as you want to, really expand your research. So it's going to generate a summary of each website that it went through. And then once it does that, it's going to basically do a follow-up decision. This is an agent that will decide based on the current findings that we have in the original query. Should we generate some more queries and research those ones? Or do we have enough information to make a final report? So in this case, it decided we need to ask more questions. So it tells you the reasoning. While the current findings indicate that fluoride in drinking water is beneficial for dental health and the recommended level is considered safe, blah, blah, blah. So here's the follow-up queries. What are the potential side effects of fluoride in drinking water for adults? What is the recommended fluoride concentration for children compared to adults? And such. So this will go on to stage 2 or iteration 2 of the same process. It'll go through every single query, find a website for it, summarize it, and compile it together. And now it's going to decide again, does it have more questions it wants to ask? Or does it have enough information to make a final report already? So it decided again, I'm going to ask more questions. So we go into stage 3. It's going to search more stuff and compile the results. So the maximum total iterations of research that you can do with this current setup is only 3. You can make it whatever you want depending on how much tokens you want to spend. But now that we've reached the max of 3, we're going to combine all the results together from all the websites, all the summaries, and send it to a final synthesis agent, which will take all of that and create a final markdown report for us. So it has a table of contents with every section, as an introduction, all these sections here, a conclusion and sources. So I don't know about you guys, but I think that's really cool, especially the table of contents and the formatting and everything like that. You can even make this bigger if you want to. It's pretty short. There's only like a couple sentences per section, but you can expand that. That's just something you can control in the prompt. I limited it just to save on money, but you can make it as detailed as you want, okay? So hopefully you guys find this to be interesting. I think this is a great way to replicate what we just saw with Grok and Gemini, and also ChatGPT has that same feature. So if you are interested, then keep watching. So I made a little flowchart here so we can understand how this is going to work a little bit better. So when you first ask a question like, is water good for you? Whatever query you have will go first to the query agent. And this agent has the responsibility of thinking of things that we're going to search for on the internet using DuckDuckGo search or Google or whatever you're connected to. So this is going to come up with on its own different subqueries like benefits of drinking water for health, how much water should you drink, daily guidelines, impact of dehydration on health. So it helps us cover a variety of different things that we can search for to get a variety of sources back so that we can make our final search report, okay? Because if we were to just search in DuckDuckGo, for example, is water good for you, you're only going to get a limited amount of information. It's probably going to answer the question, is water good for you? That's a very obvious question, of course. It's just an example here. But if we have more complex questions, it makes sense to search for a bunch of different things rather than just one thing, okay? So it just breaks up a query into subqueries, that's it. And then it also gives you the reasoning. Once we have our generated search queries, we're going to feed them into the DuckDuckGo search API. The reason we're using this one is because it's completely free. So for every single search query, we're going to use DuckDuckGo search to get at least one website URL. You can expand it to get other websites, like, 3 or just however many you want. It just costs more when you're actually scraping them and analyzing them. So for now, we're going to take one query. It's going to output one URL, the top result. And for every single URL, we're going to send that to the search agent. And we're going to tell the search agent to use a tool called URL scrape. And this is simply going to scrape the content of the URL, the actual website, and return it as text so that it can generate a summary. So this will have the responsibility of, one, scraping the website using the URL scrape tool, and also generating a summary of the content of the website. So just like a paragraph, for example, of what it finds. So the search agent will be invoked for every single subquery that we have originally generated. So at the end of it, there should be 3 different summaries for the 3 different search queries that we have, because they each have one website that we're scraping, right? So after that, we should have all of our summaries, and now we're going to come to the follow-up decision agent. As we saw in the example, this is the agent that has the responsibility of deciding if we have enough information to answer the original question, or if we should go back to the query agent to generate more examples. So what it will do is return a boolean yes or no if we want to follow up or not, as well as the reasoning for why we should follow up. So if it's yes, we're essentially going to go back to the query agent to generate more subqueries to just repeat the process. So we'll go from iteration 1 of this cycle to iteration 2, iteration 3 for as long as it wants to, or if we reach the limit of 3 iterations of querying and searching, okay? So finally, once the follow-up decision agent has decided no, it does not need to follow up, or we reach the max, it's going to go to the synthesis agent. This is the agent that has the responsibility of taking all of the summaries that our search agent has generated from every single subquery and summarizing it completely into a final report. So with a table of contents, citations, everything like that. So this is the actual final report making agent. And that's how it works. So they all work together to achieve the end goal of generating a final report based on an original query, is water good for you, for example. So I really hope that makes sense. Now let's jump into the Python code and see how we can get started making this. Okay, so I started by making a deep research subfolder in projects. And within that, I just created a new Python environment. I created a main.py file, it's empty right now, and also an empty requirements.txt. So first, let's just put all of the packages that we'll be using. So we got Pydantic, DuckDuckGo search, BS4 for beautiful soup, that's what we'll be using to scrape websites, requests for also the same thing, and then rich. Rich is a cool dependency that we can use to output stuff to our console in a nice way. It makes it look much nicer and has some cool features versus just using the regular console output like print, just the print function, So it adds some colors and other cool functionality. We have python.env, which we also have been using to get the local environmental variables from the .env file. And then finally, of course, we have our OpenAI Agents library, the most important one. After you add all your dependencies, you can then install it to your local Python environment by doing pip install -r requirements.txt. So this will install all the dependencies to your local Python environment. Make sure that you activate it, of course, before running this, and then you'll be good to go. The very first thing that we want to do first is just call this load.env function so that we can load our OpenAI API key so that we can actually use the OpenAI models. All right. After that, we want to do console is equal to console. And we're just going to import console from the rich library that we installed. So you can do from rich.console import console like that. So this will basically allow us to interface with the console output so that we can print some really cool stuff like I mentioned before. Here's our main function, it's async because when you call agents by default, it's using async. So we'll also make main async as well. And then we're going to call it using async IO run. So let's just make sure that we can run this to start with. So Python main, and it says yo, nice. So it's working perfectly. So we can do console.print, and then we could say bold cyan, and then bold cyan as a closing tag. So in between these two tags here, you can say any text like deep research tool, and it will be that color. And then we can say console edition. This tool performs in-depth research on any topic using AI agents. So if we just run this again, let's see what it looks like. There we go, deep research tool. It's in a nice blue color, console edition. So now the very first thing that we want to do to actually get this to work is get the user's query, because the whole point is we want to research based on user's query. So we want to get the actual query from the user. And we could do that by doing query is equal to, and we can say prompt. We can import prompt by doing from rich.prompt import prompt. So prompt.ask, we can ask the user a question. So say in bold, what would you like to research? So we're going to ask that, and then the response will be in this query variable here. So we'll do some basic validation, just make sure it's not empty. So we'll do if not query dot strip. So this will make sure to strip any white space. And this will be triggered if it's actually nothing but white space. So we could say console.print in bold red error, please provide a valid query. So now at this point, we're actually going to use that query to do stuff, to actually do research, okay? The way we're going to do this is we're going to make a new file called coordinator. This is going to be, the responsibility of this class within this file is going to be to coordinate all of the agents. They're going to work together in a deterministic fashion. So we're going to first call that query agent that we saw, and then that will hand off to the search agent and all that good stuff, okay? So we're going to do class research coordinator. We'll pass in the query when we instantiate this, and then we'll do self.query is equal to query. And now we can also add a research function which will kick off the research using that query that we set before. And it should return a string, which is the actual research report that we're going to print out to the user and also save to a file, okay? Now, before we learned about traces, which is a way to see what the agents are actually doing when you call your workflow. So we're going to be utilizing this here so we can actually make sure that everything's working correctly if there's any errors or anything like that, and also debug. So we can make a new trace and just call it research workflow. How about deep research workflow? Like that. And we'll just import trace from OpenAI agents, from agents import trace. There we go. So now anything that's out of here, of course, as we know, will be traced within OpenAI's platform, okay? All right, so step one is to send the query, the original user query, to our query agent. So we're going to make a new subfolder called, let's say, research agents. So all of our agents are going to live inside of here. It's just a way of organizing things. So new file, we'll say query agent.py. So let's define our agent. So agent, and the name is going to be query generator agent. So the idea behind this agent is we want to take the original query and then break it down to actual search queries that we can search on and then summarize those results, right? So we want to come up with a good enough prompt so that the agent can do that. So I'll just go ahead and give you the prompt that I came up with, and you can let me know what you think about it. But it says you are a helpful assistant that can generate search queries for research. For each query, follow these steps. Number 1, first think through and explain. Break down the key aspects that need to be researched. Consider potential challenges and how you'll address them. Explain your strategy for finding comprehensive information. And then 2, generate 3 search queries that are specific and focused on retrieving high quality information, cover different aspects of the topic. And this is kind of what I mentioned before. If we just take the original user query and then search based on that, you're going to get a narrow set of websites that sort of talk about that thing. But if we have the agents here break that down into a bunch of subqueries that really expand outward, we can get more information and summarize it all together. So that will help the research. And then will help find relevant and diverse information. So kind of the same thing. So always provide both your thinking process and the generate queries. So let me explain what this is doing here. So first of all, number 1, this is just the thinking process. So it's just, that's why we're saying break down the key aspects and everything like that. So sort of think through everything and explain your strategy. And we're going to have it return that in a second. And then 2 is the actual part where it generates the queries, okay? So the reason I broke it down into this way is because I mentioned this before as well. Models tend to perform better when they have to explain their thinking process. So that sort of helps it think. It's not actually thinking, it's sort of simulating thinking and how humans think, but by just predicting the next token. But it does help the output. Okay, so what we're going to do is have a class query response from base model. This class will represent the return type of this agent after invoking it. So we'll say queries, which is just a list of strings. So these will be simply the queries generated by the agent, and then also thoughts. So this will allow us to show on the front end, which is just in the terminal for this case, what the thinking process is of the agent as they're thinking through it. And that looks cool, but also, like I said, to make it better, just overall. There we go. So finally, we can now provide query agent prompt and then also the output type as query response. So hopefully that makes sense. Hopefully it's not too complex. And the final thing that I'll do is I think while you're making an application like this, you should just use a cheap model just while you're testing, because when you're making an application like this, you have to run it a bunch of times to make sure that it's actually working. So I think it's better to use a dumber, cheaper model so that you can save money on tokens. Okay, and then whenever you have, of course, deploy it, then you switch it to a better model like GPT-4o or something more advanced than that. All right, so now back in our coordinator, let's actually call it. So to make this more modular, we're going to make a separate function just for processing this agent. We'll just have this directly return the query response type that we created in that other file. So we can go ahead and import that like that. So let's run the agent. Result is equal to await runner dot run query agent. We'll import that. And then the input here is simply going to be the query that we're storing in our research coordinator instance. So we'll do boom like that. So hopefully everything works correctly. It should pass in the query, break it down into subqueries, and return it as a query response into the result here. So we could do return result dot final output. But of course, this is kind of basic. What we want to do is kind of spice this up a little bit so it makes it look nice in the console while it's actually doing things. We're going to start by initializing another console instance. So console is equal to console from rich again. And then now back in our function, I'm going to replace all this with this. This will just spice it up a little bit. So we're going to wrap everything with console.status. So basically status will show it. You'll see what it looks like. It's really hard to explain, so it's better to show you in a second here. And it'll show the status indicator with bold cyan analyzing query, so ... analyzing query. It's just going to show that while all of this is running. Once it finishes, it's going to finish showing that, okay? So it's going to run our agent as we already had, and then after the agent returns its result, we're going to display the results for the user to see. So we're going to print out in a panel, which you'll see what that looks like in a second, query analysis, and then we're going to show the thoughts. So this will just show the thoughts from our query response. So we have both the queries and the thoughts, so we're just going to print out those thoughts so the user can see, and then we're going to print out each generated search query as a list. So now with this function, we can go back to our research function and call it. So do query response self.generate queries. There we go, as a function. So let's just stop here and run it, because this is enough to run the first agent, and we're just going to have the response here. And then after we confirm that it actually works and it looks good, we're going to use this query response to go to the next step. All right. So with our research coordinator, we're going to go back to main.py and create a new instance of it once we get our query. So we'll do research coordinator is equal to research coordinator, just import that. And then with that, we can now do report is equal to research or await research coordinator research. Boom. So it's going to research based on the query that we passed in before and give us a report, which for now, just to keep it simple, we're just going to print out. Also make sure you call await because it's an async function. So now if we run it, let's try it now. Let's do python main.py. What would you like to research? I'll say, is water good for you? And let's see if we can generate. So here we go. Here's the status thing I was telling you about. So while it was doing the stuff within the status, let me go back to the code here. While it was doing the stuff within here, it was showing at the top analyzing query with a nice little loading indicator. So it looks really cool, gives it a nice snazzy kind of look. And then once it's finished, we got our query analysis. This is the panel that I was talking about. So that's what a panel looks like right here. And then we print out the thoughts. So to explore whether water is good for you, we need to consider several key aspects, blah, blah, blah. So it gives you the reasoning for why it came up with these generated search queries. Number one, benefits of drinking water for health. So it would search that. Effects of dehydration on the body and optimal daily water intake recommendations. And this is us just printing out the report. So the query agent is working perfectly as we intend it to be. So now we're going to move on to the next stage, which is taking these queries that have been generated and actually getting some URLs from them and then searching those URLs to summarize them, okay? So we'll make a new function here that takes in our list of queries that were generated. And now we're going to need another function to go along with this that will actually use DuckDuckGo search. So for this one, we'll do define DuckDuckGo search. It takes in a query string. So again, just to remind you, the reason that we're using DuckDuckGo search is because number one, it's free, so that's good. But the primary reason is we need a way to take a query and get search results for it. So get links that we can then scrape and then summarize for the synthesizer, okay? So the DuckDuckGo search will do the part of getting the links for a query. So we'll do results is equal to, and you're going to do ddgs for DuckDuckGo search, which we just need to import. There we go. And then we're going to do dot text. So we're searching for text, passing the query that we're trying to search for. And then here's supplemental information like the region. So the United States in English. Safe search is off, so you can make that on if you want to, keep it PG, I guess. And then you can set a time limit. So yes, there's a time limit before it times out. All this one means is that for this query that we provide to this, we're only going to get one link, one search result. If you want to provide a list of 3 links per query to our search agent, for example, then you just set it to 3 and you'll have more to search, okay? So this will return a list of dictionaries with the actual key value pairs of the data that we're trying to extract from this. So it includes the URL and stuff like that. So we'll just do return results. And they're just going to go and wrap all this in a try catch just to make sure that we handle any possibility of an exception occurring in a way that does not break our application. So we can do accept exception as EX. And then if an exception occurs, first of all, we're just going to return an empty list. So basically, it just returns an empty list as if it found nothing. And so our application should still work in the event that this one for some reason fails. So that's a good little thing that you can have. And then otherwise, we're also going to print out a message telling the user that this happened. So in bold red color, search error, and then list the exception reason with that here. All right, so now we can come back here. And so what we want to do is get all of the search results for each query. So we're going to make a little temporary data structure to store this. So search results is equal to this. And then for every single query that we're passing in, so for query and queries, we're going to call our function. So self.duckduckgo search, passing that query. We're going to store it by the query. So all search results query is equal to search results. So that later on we're actually accessing this, we can associate our search results with each query, okay? Okay, so now that we have our search results, which are just the links for each of the queries, we now want to make our search agent, which is capable of actually searching each of those URLs. So we're going to go back to search agents, make a new file, search agent. All right, so here we got a search agent as a search agent prompt, which is empty currently, and we're using GPT-4o Mini. So before we define the prompt, what we want to do is give it a tool, and this tool is going to be the tool that the agent can use to scrape a URL that is given. So I showed you this in the flowchart at the very beginning. So we're going to use function tool, and the name of the function will be just URL scrape URL string, and I return to a string of all the content of that URL. And for this, I'm just going to copy and paste it because this is actually pretty generic code you can find for scraping a website. What we're going to be using is the requests library that we set in our requirements, as well as beautiful soup. So the purpose of requests is to simply call a GET request to the provided URL, and this simply returns the contents of a website. It returns the actual raw HTML of that website at the URL, if it can. If it can't, it'll just raise an exception. After that, we're going to do the part of using beautiful soup, which is a nice little utility library that we can use to take text and parse it in different ways. So in this case, we're taking the HTML that we've grabbed or scraped from this URL, and we're converting it to just raw text. So basically, once it's outputted by this, it'll just be raw text for the large language model to work with, because it's not really useful to have like the p tags and the h1 tags and all that stuff that a HTML file has, right? So that will do that. It's just extracting all the data pretty much and appending it to text here. And then what it's doing here at the end is we're limiting it to just 5,000 characters max. You could, remove that limit or extend that limit if you want to. We're just making sure that the large language model, of course, has a limit. There's only so much you can fit into the context a window of a model like GPT-4o Mini. So that's why we're doing this, just to make sure that does not go over that limit. But now we can give the agent access to this tool by doing URL scrape. So again, it takes in a URL, it scrapes the website for the content, so it gets all the text content of that website at that URL and returns it as a string for the agent to use. So now here's the prompt. You are a research assistant. Given a URL and its title, you will analyze the content of the URL and produce a concise summary of the information. The summary must be 2 to 3 paragraphs. Capture the main points. Write succinctly. No need to have complete sentences or perfect grammar. This will be consumed by someone synthesizing a report, so it's vital that you capture the essence and ignore any fluff. Do not include any additional commentary other than the summary itself. So Basic idea is that you're given a URL and the title of the website, and you need to scrape it and just return a summary of the content that you scraped from that website. So that's it. So this is a great agent overall because the whole purpose of an agent really is to have a narrowly focused task that it can perform, and this is exactly what that is, and it has a tool to do so. So the cool thing about agents and the specific SDK here is that you don't have to tell it to use the tool. It does help to tell it that it needs to use the tool because sometimes it just won't use it. But in this case, it should be pretty obvious to our agent that it should use URL scrape to scrape the contents of the website and then summarize based on the information. So if you find that it does not do that reliably, then just add something to the prompt telling it to do that. Something else that you can do that I never really showed is that you can actually leave comments, like a doc string here, explaining what the function does. So scrapes a website for its contents given a URL. What's cool is that function tool annotates this, function as a tool that this agent can use, but behind the scenes, it actually lets it access the doc string as well to read the documentation for the function to help it understand what the function actually does. So that's another little cool thing that this library provides for these agents. So now that we have our agent here, let's go in and actually use it in our coordinator. So for every search result that we have for every URL, we want to send it to the agent and then get the summary and store it. So we'll do for query in queries. And then for each query, we're just going to print out the current one that we're searching for with this piece of text here. So searching for query. So it's going to pretend like it's searching even though it already did it above. You could do it here if you want to. It's really up to you. And so now we want to do for result in all search results query. So basically what this is doing is accessing the URLs that you found for that query that we set above. Of course, there's only one per query, but it doesn't know that. You can, again, set this to whatever you want, and it will be inside of here, and it will loop through it here. We want to send that to the agent. So we can do agent result is equal to, and we could say await runner dot run search agent, which we need to import above. And then we have the input, which is going to be a string that contains, like we told the agent that it should expect a URL and the title. So that's what we need to provide. So in the search results that we got from DuckDuckGo, it actually does contain that. So we can craft a little string out of that by doing search and then here. So we're doing title, then result, and then accessing the dictionary. So we're pulling out the title from the result as well as the actual URL, which is href. So we're going to take the search input and provide it to the agent. And now we need a way to take our summary along with the title and URL and essentially store it together. So at the very end, we can feed that to the synthesis agent. So we're going to make a custom class for that. I'm going to make a new class within here called just models.py. Inside of here, we're going to define a class search results. And a search result is going to have a title, a URL, and then the actual summary of that content. And so now back here in our coordinator, we can then create a new instance of our search result. So search result is equal to search results, which we're going to import. We'll store the title. So result title. We'll store the URL, result href, and then our summary, which is going to be from our agent result. So agent result dot final output, like that. And then now we just want to store the search result, which we will do by first initializing it. So when we create a new instance of research coordinator, we're going to do self.search results is equal to an empty array or list. And then now finally down here, when we're actually doing the searching and stuff like that, we can do self.searchResults.append search results. Okay, I really hope this is making sense so far. Again, we're just taking each of the queries, we're getting a URL for each of the queries or however many you want to grab. And then for every single URL, we're going to send that to the search agent, which is going to summarize it. And then we're storing all the summaries in a search result object that is stored in a search results list for later access, okay? Now what I'll do is I'll just spice this up a little bit with our console outputs. So I'm going to print, first of all, every time we go for a specific search result, we're going to print out results and then the title and then the URL. So it basically lists what URL we're currently analyzing. So we'll say analyzing content. Something else that we're going to do is clock the time right before we start searching so that we can basically track how long it took to do the analysis with the agent. So we could say analysis time is equal to time to get the current time minus the time that we tracked before we started. So which we can then output at the end here. So we're saying analysis completed in however long. seconds. We also want to output the summary from the agent, which is probably too big to directly output to the console. So we'll just generate a preview of that using the first 100 characters, and then we'll print it out. So summary and then summary preview. So it's going to look nice. So I know it's just a lot of copying and pasting, but I really don't think it's useful for you to see me type all this out. I don't think that's useful at all. So hopefully my explanation is enough to make this make sense, and then you'll see what it actually looks like in a second, okay? All right, so the very last thing at the very end of the function, outside of all these loops here, we're just going to print out a final message. Research round complete, found however many search results across however many queries. So now back in the top of our coordinator in research, we can then finally take our query response and send the queries to our perform research for queries function that we just created by doing queries is equal to query response dot queries. We only want to send the queries. We don't care about the thinking process. We already printed that out in this function here. So let's run this now and see if it works. So we'll say, what is the best gaming PC? Analyzing query. So it's going to break it up into those subqueries. Here they are. So best gaming builds 2023. So it's searching for best gaming builds 2023, the title, the URL, analyzing content, the summary preview, and then analysis completed in 4.49 seconds. So it's doing that for each of the results that we got from DuckDuckGo for each query. Great. And then it says research round complete, found 3 sources across 3 queries. Amazing. So it's working perfectly so far. Very happy with this. I really hope you guys find this interesting as well. Okay, so the next step is we have kind of a decision we can make. We can implement the decision-making process, like the follow-up decision process, or we can first do the synthesization of the query search results. So let's do that part first. Let's actually make the agent that can do the final research report, because I think that's more interesting. And then we'll add back the part to do the follow-up decision afterwards, okay? All right, this agent is going to be pretty simple, so I'm just going to paste in and explain how it works. This agent is called synthesis agent because it's synthesizing all of our summaries and outputting a final research report as a string. We're going to use model GPT-4o because that's a more powerful model than the other ones. I believe that this last stage is the most important, and it requires just a better model overall. I think that makes sense intuitively, so that's why we're going to use a better model for this. But like I said before, if you want to, while making this, switch it to a dumber model, that would make a lot of sense. Anyway, so the prompt is you are a research report writer. So that's basically the identity of the agent. You'll receive a original query, so the original search query that the user provided, followed by multiple summaries of web search results. Your task is to create a comprehensive report that addresses the original query by combining the information from the search results into a coherent whole. The report should be well structured, informative, and directly answer the original query. Focus on providing actionable insights and practical information. Aim for 2 to 3 pages with clear sections and a conclusion. Added this one because this is just controlling the amount of information that is outputted by the research report or in the research report. And then this is just telling it to have clear sections like a introduction, conclusion, and then sections in between like a standard research report paper. Also, this one's a very important one that I added. Use markdown formatting with headings and subheadings. Have a table of contents in the beginning of the report that links to each section, and then try to include in-text citations to the sources used to create the report with a list of sources at the end of the report. So this is just a nice thing to have so it looks more visually appealing when you're reading the report. Markdown is great for that kind of stuff, as you know. So that's it. So hopefully that explanation makes sense. Let's now try using it in our coordinator here. So we're going to make a new function, synthesize report, and it's going to return a string of the actual report. So the input, as we told it in the prompt here, should be a original query, so the original user query, followed by multiple summaries of web search results. So again, we'll need to craft a string that will encapsulate all that so we can send to the agent to read. So let's do this. So we're going to make a new string. It's going to start with the original query, so the original query, like what's the best gaming PC. Then we'll do 2 new lines, so there's a line of space in between. Search results, new line. And now we're going to loop through all of our search results that we're storing. So search results, we're going to loop through each one. And now we're just going to concatenate onto this string here the title of the website, the URL, and then the summary that was generated by the search agent. So it's going to have all of that, and then the synthesis agent will synthesize that into a final research report. So hopefully that makes sense, which we will then return by doing results.final output. Finally, we'll just wrap everything with console.status again. So it's just going to have that loading indicator indicating on the console what it's doing. So synthesizing research findings, it'll show this while it's actually hitting the synthesis agent and waiting for a response, okay? Okay, so now after we perform our research, we can then call final report is equal to await self.synthesize report. So it's going to synthesize the report, return it as a string, which we can then finally return here. I'm also just going to print it here. You can also print it back in main like we're already doing. So let's just get rid of this like that, and then we'll print it here. So research complete is going to show that in green, and then we're going to use the markdown. There's actually a built-in markdown thing that we can use to actually show our markdown report from our agent in markdown formatting. So there's only one way to see how it looks. Let's actually run it and see what we get. So what is the best gaming PC? So it's searching each URL, getting our summaries together. Here we go, research round complete. Now synthesizing research findings. There we go. Here we go. Look at that. So very detailed. So this is where our markdown component that we just imported comes in. It shows a title and it's all formatted as you can see. So it looks really good. So we have our title, Best Gaming PC, a comprehensive guide, table of contents, looks great. Introduction, selecting the best gaming PC involves evaluating a multitude of factors, blah, blah, blah. So it gives all the factors that we want to generate, some top picks, and then we get a conclusion. So it doesn't necessarily recommend it in this final conclusion, but it does find all the options for you from these different websites. So pretty good overall, I would say. But it's limited because, of course, we have not implemented any follow-up research. I think that's what makes it deep research actual deep. It should be able to dig through the results continuously and come up with new things to search to really dig down and find an answer to the question that you ask. So what we're going to do now is before we generate our report, we're going to decide here if we want to generate more queries to dig deeper, like I just said. And then if we do decide that we want to do that, we're going to then search them again, add it to our findings, and then finally decide again. It's just going to be a continuous loop until we either reach the cap or we are done, and then we can finally generate a report with all the information, okay? Okay, so every follow-up decision should have, of course, if we're going to follow up or not, so should follow up. We're also going to have the reasoning for why we should follow up for the same reason that we had before. Just having reasoning is, one, informative, but also can help performance, I think. And now something else I decided is that instead of sending back to the query agent, which will generate queries, we're going to have the follow-up agent actually generate the queries to follow up based on. So this is really up to you how you want to design this. The reason I kind of did it like this, where the query agent is only for the initial queries, is because right now it sort of just expects that original user query and then generates subqueries based on that. I didn't want to have to adapt it so that it also has to worry about follow-up queries. So based on queries that you've already generated and also the original query, but also generate new queries based on that. I just thought that was a little too complex, so I instead opted to put that complexity in the follow-up decision agent. So one, it's deciding if it should follow up, but two, it's also giving the questions that we should ask. I think that also makes a little bit more sense. Since this agent is deciding if we should follow up, it already has an idea of what questions we're missing, so it can generate those subqueries for things that it wants to know. So hopefully that intuition makes a little bit of sense, but again, you can design it however you want to. So I'm going to do queries, and that's going to be a list of strings. So here's the prompt. So you are a researcher that decides whether we have enough information to stop researching or whether we need to generate follow-up queries. You will be given the original query and summaries of information found so far. So I added an important note here. So for simple factual questions like how long do dogs live, or is water good for you, or what is the height of Mount Everest, if the basic information is already present in the findings, you should not request follow-up queries, because without this, it was asking for follow-up even though, water is obviously good for you, and also we already know what the height of Mount Everest is. That's a fact, and also we already know how long dogs live, generally. That's not like a deep question that requires super deep research. So I think only one iteration of research for that makes a lot of sense. So there's no need to keep digging, essentially. So for your simple factual questions, only do one iteration. Do not ask for follow-up, okay? Complex questions about processes, comparisons, or multifaceted topics may need follow-ups, but simple factual questions rarely need more than one round of research. If you think we have enough information, return should follow-up is equal to false. If you think we need to generate follow-up queries, return should follow-up is equal to true. I'm just being very explicit to make sure that it knows what it needs to do. And then if you return true, you will need to also generate 2 to 3 follow-up queries that address specific gaps in the current findings. Always provide detailed reasoning for your decision. So here's our agent follow-up decision agent, instructions, our response output type, and then we're using GPT-4o mini. All right, we'll use it now. So we're going to add the concept of an iteration, which will just keep track of the current iteration that we're on. So it'll be 1 by default because doing the original query generation as well as the research is the first iteration, and then any follow-up that happens will be the next iteration, and so on, okay? So to do the follow-up, we're going to have a loop so that we can continuously do it, and the condition of the loop will be self.iteration is less than, and then you could just make up a number like 3. So the max amount of iterations is 3, so as long as the iteration number is below 3, we should be good to go. So now we'll need to call a method that actually does the decision-making process. We'll make a separate function for that. So define generate follow up. First, we need to generate the text that we're going to feed into the follow-up agent. So it's going to be the original query as it expects, as well as the current findings. So every single URL and its summary. So to use that to make its decision. So we could say now result is equal to await runner.run follow up decision agent input is equal to findings text. So we'll display the result to the user so it actually knows what it decided. So it says follow-up decision, and it's going to say decision. So if it's true, it'll be more research needed, and if it's false, it says research complete. And then it gives you the reasoning for why it made its decision or print it out directly. And then also, if the follow-up is true, if it decides we want to do follow-up, it's going to print out each of those follow-up subqueries that we're about to search through, okay? And then finally, we can do return result dot final output. And then just like before, we're going to wrap everything with this status. Okay, so finally back in our while loop here, we're going to do decision response is equal to await self dot generate follow up. And that's it. So generate the follow up, and then depending on the response. So if not, just decision response should follow up. So if this is false, then we're good to go. So we can just go ahead and print out no more research needed, synthesizing report, and we'll break out of the loop so we don't have to keep researching. And then after that, if it makes it past this point, then obviously should follow up is going to be true. So we're going to actually do the follow up now. We're going to say conducting follow up research and then list the iteration number. And let's make sure to increment that iteration number to the new value, because we're now, before we were on iteration 1, and then next will be iteration 2, 3, so on, okay? So we want to reflect that new value. So finally, the last thing that we need to do, since we know we should follow up, we know that this has the subqueries, let's actually perform the research for those subqueries. We'll just copy this and call it directly inside of here, except we're going to replace this, which is our original response for our queries, with our decision response queries, and it should generate summaries based on those original ones. And that's it. So once the loop has finished, we've done all of our follow-up, we got all of our research completed, and now we can synthesize a report as we've already been doing. Let's just do the same query as before, and let's see if it decides to do follow-up or not. Research round complete, found 3 sources across 3 queries, evaluating if more research is needed. So it's doing the follow-up decision process. Follow-up decision, research complete. So the current findings provide a comprehensive overview of the best gaming PCs, including budget, mid-range, and high-end options. So no more research needed, synthesizing report. So it decided not to do follow-up research. Okay, that's fair enough. So it is working in the sense that we can call the agent and get, a decision. And we also got the reasoning for that decision, which is great. It gives us insight into why it decided that it's enough information. So what I'll do now is just replace this query with a more complex query. We'll do the original one so this is a more complex one that probably needs a lot more research and more follow-up and stuff like that. So I'll let this one run and let's see what happens. Here we go. So I decided more research is needed. So while we have substantial information regarding the benefits and safety, the current findings lack a comprehensive exploration. So what does it want to know more about? What specific health risks are associated with excessive fluoride exposure in drinking water? What are the latest scientific studies or reviews regarding the neurotoxic effects of fluoride? So it's doing that research, and now it's evaluating again. More research is still needed. So what are scientific health risks associated with fluoride exposure in children and pregnant women? Great. So it seems to be working well. It's doing as much research as it needs. So now this is the max amount of iterations that we can do, 3. So now it's synthesizing automatically. So we should get a full report any second now. Here we go. Here's our full report. So it works great. I don't know about you guys, but I think this is a really cool tool. So that's actually it. There's nothing much more I want to show you guys. I want you guys to now try and think about more ways that you can improve this. I can think of a few myself. The number one thing that we can do is increase the number of search results. So if we go to DuckDuckGo search, let's increase it from max results 1 to, let's just say, 5, so that it can compile a more wide range of results from these websites. And then also in our final report, in our synthesis agent, let's just make it so that it can do up to 5 to 6 pages, and that should be a little more comprehensive, I think. So I'll ask this query. So let me just let this run for a little bit. So it should get a lot more research done. So I'm sure there's ways that you can design this a little bit better. The things that I just changed just now are pretty simple, depending on our current architecture. So I think a really big part of this is making the search agent more advanced, because right now you just give it a URL and then it scrapes it and gives you a summary. I think a cool feature would be that when it scrapes this website here, every time it finds a useful URL, it can actually click it using a tool and it goes to that website and scrapes that one as well. So it can hand off to another agent and they work together to essentially summarize, like go down a rabbit hole of websites and stuff like that. I think that'd be really cool. That gives it a lot more capability, because when you're researching something yourself on the internet, you go to a website, you click things on that website, you go back, go to a different website. It's just a lot of clicking, and giving that agent the capability to do something similar would, I think, make it a lot more powerful. Yeah, there's just stuff like that that you can do and add to this to make it much more capable. But I think overall, unless you disagree, let me know in the comment section below. I think this is a very cool tool that sort of generally mimics how the other deep research tools I showed you are doing things. So as I'm talking, it's still doing the deep research because it has to analyze a lot more results here. So up to 5 per query. So look at that. It's a lot more. A lot more. Another thing is that sometimes you'll notice that it goes to a lot of the same websites over and over. That's just a small fix you can add. Just add a way to check to see if you've already looked at the URL or not. Okay, we finally have our final report. So it did a lot of digging, which is great. So let's just take a look here. Comprehensive report on the effects of fluoride in drinking water. We have a few sources listed. I guess it selected the most important ones for this report here, not literally everyone that we search, which makes sense. You don't use every source that you look at. Anyway, so this is working great, as you can see. I'd love to hear what suggestions you guys have for how to improve this, like I mentioned before. This is just one application you can make using the Agents SDK from OpenAI. Overall, though, guys, I really hope you enjoyed this series. It was fun to create. It's a really fun SDK that you can use to make these agents. And if there's anything that I missed that you guys are confused about or anything like that, then please let me know in the comment section below. But if you made it this far in the series, I really thank you for watching. Thank you so much for the support, just taking the time to watch these videos. It takes a lot of my time to create these videos, so thank you for your time as well. I'm really into the AI and machine learning stuff, so if you have any ideas for future videos, then please let me know. I'd love to look into it. And yeah, that's it. So now you guys, after watching all these videos, should know how to make large language model agents using the OpenAI Agents SDK. So thanks for watching, everybody. I will see you guys next time, and peace.